Good morning. It's still only 6 o'clock. Be quiet. No one's awake yet. All right, I'm waking up. Let's get in the frame of mind. Hey, good morning. It's Mike again. All right, so I hope you have your coffee. This curtain wall section is pretty long, and we're going to be getting into complex curtain systems as if we haven't already. But if you follow my line of reasoning, we're right on schedule. We're on chapter 13, page 559. This curtain wall section is pretty long, and hey, good morning, it's Mike again. Alright, so I hope you have your coffee. This curtain wall section is pretty long, and we're going to be getting into complex curtain systems as if we haven't already. But if you follow my line of reasoning, we're right on schedule. We're on chapter 13, page 559. Replacing panels and mullions. Next, you will replace panels in the wall you just created. As we explained earlier, panels are subcomponents of the overall curtain wall, so you may need to press the tab key to select a panel and its view properties. Special selection tools for curtain walls are available in the context menu. When you highlight a mullion or panel, so you may have to hit the tab key. As you can see, as you hit the tab, you hover around, you're selecting mullion, panel, segment. curtain wall grid. So you could see, you could move the whole mullion with just the individual segments. If you unpin it, you can see, if indeed you want it to move, make continuous, break at joint. Alright, so before I jump ahead, how segment. Select special selection tools for curtain walls are available in the context menu. You are curtain wall grid. So you can see, you can move the whole mullion with just the individual segments. If you unpin it, you can see, if indeed you want it to move, make continuous, break at joint. Alright, so before I jump ahead, into the narrow along the horizontal grid. Go to the type selector and find the type name solid under the family system panel. Note that the glazing panel type is in the same family as the solid panel. Well, at all. Well, therein lies our first challenge of the morning. You would think first thing you need to do is put this back. Hey, good morning, it's Mike again. Alright, so I hope you have your coffee. This curtain wall section is pretty long, and we're going to be getting into complex curtain systems as if we haven't already. But if you follow my line of reasoning, we're right on schedule. We're on chapter 13, page 559, replacing panels and mullions. Next, you will replace panels on the wall you've just created. As we explained earlier, panels are subcomponents of the overall curtain wall, so you may need to press the tab key to select the panel and its view properties. Special selection tools for curtain walls are available in the context menu. When you highlight a mullion or panel, so you may have to hit the tab key. As you can see, as you hit the tab, you hover around, you're selecting mullion, panel, segment, curtain wall grid. So you can see, you can move the whole mullion with just the individual segments. If you unpin it, you can see, if indeed you want it to move, make continuous, break at joint. Alright, so before I jump ahead, select special selection tools for curtain walls are available in the context menu when you highlight a mullion or panel. It removes segments. I pick just that. Make continuous, extends the ends of mullions at a joint so that they display as one continuous mullion. If you notice the difference, after placing mullions on a curtain wall, use this tool to control mullion joints. So as you can see, if you look really carefully, the image on the left butts up to the underside of the mullion above it. Then you have the figure, as well as the mullion in let me rephrase that. The horizontal elements of the mullion are flush with the outer edge of the side mullion, the vertical mullion. In the left figure, in the center figure, those same mullions are now flush to the inside of the vertical mullion. So this makes continuous, it extends the ends of mullions at a joint so that they display as one continuous mullion. Break at joint trims the ends of mullions at a joint so that they display as separate mullions. So it's the opposite. Okay. In the following exercise, you will need, or you will replace the narrow band of glazing panels with solid panels. In the 3D view, select one of the glazing panels into the narrow horizontal band. Side band, wide band. Select one of the panels. System panel, glazed. Right-click and choose Select Panels. Along a horizontal grid. With all the glazing panels selected along the horizontal grid, Go to the type selector and find the type name Solid under the Family System panel. Note that the glazing panel type is in the same family as the Solid panel. Well, it doesn't look like we can change it at all. Well, therein lies our first challenge of the morning. I can't change it. That's right, now let's click that again. You would think first thing in the morning I'd be able to do this, but as usual, maybe it's a coffee issue. Oh, I know what it is. I have my cigarette. My morning cigarette. All right. That's better. All right, so I'm going to give you a few minutes. And I need a few minutes. Well, selecting them all doesn't allow us to change the family type. But when selecting one of them, as you can see, well, this one isn't unlocked. That one's not unlocked. That's not unlocked. And that's not unlocked. Ah, they weren't all unlocked. I believe we now unlocked the family type modifier. So we change the type. So change it to Solid. And just take a quick look at some of the parameters. All of its scheduling data, all of its analytical properties, and its analytical construction. Just took off on a tangent. Notice the thermal resistance and the heat transfer coefficient. If we change that, you can see there are many variables. 3.7, 0.9. So, you'll see how all of these properties and these parameters play in to the selection of your panel glazing or your panel selection. So I want to cancel out of that. Go back in. Put this back because it remembered this was metal. We can make anything we want. Let's just give it the chrome look. Now, if you look, we changed the entire. By changing that type, we changed the entire all the material for all the types. So, properties. Special selection tools for curtain walls are available in the context menu. When you highlight a mullion or panel, so you may have to hit the tab key. As you can see, as you hit the tab, you hover around, you're selecting mullion, panel, segment, curtain wall grid. So you can see you can move the whole mullion with just the individual segments. If you unpin it, you can see if indeed you want it to move. Oops. Make continuous, break at joint. Alright, so before I jump ahead, select special selection tools for curtain walls are available in the context menu when you highlight a mullion or panel. It removes segments. I pick just that. Make continuous, extends the ends of mullions at a joint so that they display as one continuous mullion. If you notice the difference, after placing mullions on a curtain wall, use this tool to control mullion joints. So as you can see, if you look really carefully, the image on the left butts up to the underside of the mullion above it. And then the figure, as well as the mullion in the, let me rephrase that. The horizontal elements of the mullion are flush with the outer edge of the side mullion, the vertical mullion. In the left figure, in the center figure, those same mullions are now flush to the inside of the vertical mullion. So this makes continuous, extends the ends of mullions at a joint so that they display as one continuous mullion. Break at joint trims the ends of mullions at a joint so that they display as separate mullions. So it's the opposite. Okay. In the following exercise, you will need, or you will replace the narrow band of glazing panels with solid panels. In the 3D view, select one of the glazing panels into the narrow horizontal band. Side band, wide band. Select one of the panels. System panel, glazed. Right-click and choose Select Panels. Along a horizontal grid. With all the glazing panels selected along the horizontal grid, go to the Type selector and find the type name Solid under the Family System panel. Note that the glazing panel type is in the same family as the solid panel. Well, it doesn't look like we can change it at all. Well, therein lies our first challenge of the morning. I can't change it. That's right, now let's click that again. You would think first thing in the morning I'd be able to do this, but as usual, maybe it's a coffee issue. Oh, I know what it is. I have my cigarette. All right, so I hope you have your coffee. This curtain wall section is pretty long, and we're going to be getting into complex curtain systems as if we haven't already. But if you follow my line of reasoning, we're right on schedule. We're on chapter 13, page 559, replacing panels and mullions. Next, you will replace panels on the wall you've just created. As we explained earlier, panels are subcomponents of the overall curtain wall, so you may need to press the tab key to select a panel and its view properties. Special selection tools for curtain walls are available in the context menu. When you highlight a mullion or panel, so you may have to hit the tab key. As you can see, as you hit the tab, you hover around, you're selecting mullion, panel, segment, curtain wall grid. So you can see, you can move the whole mullion with just the individual segments. If you unpin it, you can see, if indeed you want it to move, make continuous, break at joint. Alright, so before I jump ahead, select special selection tools for curtain walls are available in the context menu. When you highlight a mullion or panel, it removes segments. I pick just that. Make continuous, extends the ends of mullions at a joint so that they display as one continuous mullion. If you notice the difference, after placing mullions on a curtain wall, use this tool to control mullion joints. So as you can see, if you look really carefully, the image on the left butts up to the underside of the mullion above it. The figure, as well as the mullion in the, let me rephrase that. The horizontal elements of the mullion are flush with the outer edge of the side mullion, the vertical mullion. In the left figure, in the center figure, those same mullions are now flush to the inside of the vertical mullion. So this makes continuous, it extends the ends of mullions at a joint so that they display as one continuous mullion. Break at joint trims the ends of mullions at a joint so that they display as separate mullions. So it's the opposite. Okay. In the following exercise, you will need, or you will replace the narrow band of glazing panels with solid panels. In the 3D view, select one of the glazing panels into the narrow horizontal band. Side band, wide band. In the 3D select one of the panels. System panel, glazed. Select one of the glazing
Right. Testing, 1, 2, 3. Testing, 1, 2, 3.
Horizontal band. Along a horizontal grid. Sideband, wideband. Select one of the panels. System panel. Glaze. With all the glazing panels selected along the horizontal grid, go to the type selector and find the type name.
Testing, 1, 2, 3.
On testing, 1, 2, 3. Note that the glazing panel type is in the same family as the solid panel. System panel. Glaze. With all the glazing panels selected, along the horizontal grid, looks like we can change it. The type selector and find the type.
Testing, 1, 2, 3.
On testing, 1, 2, 3. Is in the note that the glazing panel type is in this as the solid. Well, therein lies our first challenge of the morning. As the solid panel. With all the glazing panels selected, along the horizontal grid, looks like we can change it. But when selecting one of them, it's saying, well, this one isn't unlocked. That one's not unlocked. That's not unlocked. And that's not unlocked. Ah, they weren't all unlocked. I believe we now unlocked the family type modifier. They changed the type. So change it to solid. And just take a quick look at some of the parameters. All of its scheduling data, all of its analytical properties, and its analytical construction. Just to go off on a tangent, notice the thermal resistance and the heat transfer coefficient. If we change that, and its analytical construction, you can see there are many variables. 2.7, 0.9. So, you'll see how all of these properties and these parameters play in to the selection of your panel glazing, or your panel selection. So I want to cancel out of that. Back in. Put this back because it remembered this was metal. We can make anything we want. This was metal. Let's just give it the chrome look. We can make anything we want. Now, if you look, we changed the entire. By changing that type. Now, we change the entire. All the material for all the types. So, on that note,
get your business.
I want to give you a chance to wake up because we're going to go through this. We have to get through complex curtain walls today. We have to. It's part of the itinerary. So it's 4:30. I want you just to get in the right frame. And we're going to continue along. Just want to keep it short for you. We got a lot to do today. Because I have a coordination meeting tomorrow. So I'm going to be unavailable. So just hold that thought. get your coffee, and put your thinking cap on. These curtain wall systems, sometimes you create them yourself. Sometimes you create complex curtain walls all by yourself. Now, again, I start this video basing this on adaptive behavior. Now, characterized by or given to adaptation. Adaptive. As an adjective. In psychology, adaptive behavior refers to behavior that enables a person to get along in his or her environment with great success and least amount of conflict with others. I have the wrong glasses on, so hold on a second. I'm waking up. Let's get in the frame of mind. All right, so we're going to change some of these panels. As you can see, we can change one in Revit. I have Enscape open up. I have 4 days left on the trial. I find Enscape is really quick rendering engine. It's pretty intuitive, and there's not so many bells and whistles, so I have no problem with it. It's really easy to use, and it keeps it all under one roof. You don't need to run it to 14 different platforms. So I like the intuitiveness of that plugin. Excuse me. I'm most likely going to buy it. I'm sold. I'm definitely sold on Enscape. I find it to be compatible. All right, so zoom out all of your viewports. Again, grab. Let me undo this and we'll do all the panels at once. we'll do all the panels at once. Alright, so if you tab, if you can get to the panel, tab, right mouse click, select panels along a horizontal grid. We'll get all 6 of them, as you can see in the front elevation. We'll get all 6, and if you unpin them, we'll be allowed to change them all at once. So if we go to the type selector, under the system panels family type, we have 2 choices, glazed and solid. So if you look at the glazed parameters really quick, you'll see this makes a huge difference as to the overall energy calculations of the building, because of the parameters and the properties.
I'm waking up. Let's get in the frame of mind.
And wind. So let's change this to solid, and you'll see there's a default material, and for the analytical purposes, it's just metal and textile. So I hope you have your coffee. Difference. This curtain wall section is pretty from the glazed panel. The metal's more resistant, and there's more the heat transfer coefficient is higher. Okay, so just make a note of that in the back of your head. You're going to be working with engineers. You can't dismiss that fact of why the 2 curtain wall segments are evenly connected. Excuse me. We can drag that use that to extend to corner tool. We went over that. To place your corner marking, simply use the marking tool and select one of the corner edges of either one of the wall segments. Customizing curtain you have already placed in the last part of this exercise, you will practice the techniques for adding or removing segments of curtain grids to refine your curtain wall design. One important fact, this is for BIM managers. One important fact to remember are equally spaced because with curtain grids is that they're always applied, of course, with a set of the curtain wall, which we can manipulate. When we say they're implied, we mean that they are not necessarily expressed in panel elements. In other words, although a panel grid is always expressed from one end of the wall to the other, you can decide whether the grid divides every panel it crosses. To become more familiar with this technique, you will add a curtain grid at the midpoint of the right center panel and delete the division between the 2 panels. The width and height of the panel are not explicitly specified in the... Yeah, okay, so Revit, curtain walls. I have to add this caveat to this instructional course for any of you green folks out there. In the metropolitan tri-state area, especially Manhattan and any of the outer-lying boroughs, the curtain wall continuing along this morning. It's 9:19. We've got a lot done already. And again, only for those in the know. Creating complex curtain wall systems. Sometimes you create them yourself. Sometimes you create complex curtain walls all by yourself. Now, again, I start this video basing this on adaptive behavior. Now, characterized by or given to adaptation.
Adaptive.
Adaptive. And an adjective.
In psychology, adaptive behavior refers to behavior that enables a person to get along in his or her environment with great success and least amount of conflict with others. I have the wrong glasses on, so hold on a second. Now, right off the bat, today's world knows, well, that's a no-no, right from the get-go. Okay? Now, adaptive behavior has a lot to play with creating complex curtain walls. It has a lot to do with it. I'm only holding up these props. Today's world knows, so you get a better understanding of adaptive behavior and creating complex curtain wall systems in Revit. And again, props are important in science and the conveyance of an idea. Props are important. Now, we're on the cusp of a whole other world of geometry. Tools that we could use to further augment and enhance these curtain wall systems. So, again, I want to take this slow because you're going to be intimidated like I was with the math. I'm sitting there saying, I got to pre-calculus. And after that, the computer took over. So, the key to this is to just remember that Rome wasn't built in a day, and we had a lot of catching up to do. You're going to run into a learning curve. You're going to run into, and Mike, you too. Mike, left Mike, right Mike. My digital twin. You're going to run into a learning curve. Now, we're talking textures, we're talking coordinate systems, we're talking adaptive behaviors. Now, it doesn't have to be confined to a simple extrusion of glass or a solid material. And it sure doesn't have to be confined in the X and Y plane. Often, at the early stages of design, as an architect or engineer or designer, you need to be able to model curtain wall systems that indicate more complex design intent. These systems need to be flexible and light enough to allow you to explore design iteration. But they also need to be robust and detailed enough to be useful as your project moves from concept to design development and then on to fabrication. In Revit, you can build complex curtain walls using massing tools. There are two potential workflows. You can model your curtain wall systems directly within the project environment from massing forms, or you can build it as a family within a conceptual design environment. Both of these methods are quite similar, but we prefer to use the conceptual design environment because the complexity of modeled elements, such as adaptive components, is better managed in a file that is separate from the project environment. Adaptive components are an adaptation of the pattern-based curtain panel. Adaptation of the panel-based curtain. Pattern-based curtain panel. Limited slip differential. For example, adaptive components could be used in repeating systems generated by arraying multiple components that conform to user-defined constraints. Adaptive points are created by modifying reference points. Now, we talked about nodes when we were blending and revolving, and we were working on top and bottom planes and then extruding to that shape, swept blend, if you will. And we talked about the nodes that we could put in because it wouldn't really define it as a floor. Remember back in the earlier chapters, complex massing, or other techniques that we used earlier in the lessons. So these nodes or these reference points are important, and there were reference planes, reference lines, and reference points. Now, I call them nodes. We can call them whatever you want. But again, adaptive components is something that you've seen. You've seen adaptive components on your television, and you were fascinated with them, as have I been. So it hasn't taken me. It wasn't easy adapting to my environment. My environment had changed over the course of time, and I suspect I'm not the only one. We all have a change in our environment. So what just happened, for Christ's sakes, with the COVID-19. So we're going to be talking about conceptual massing and adaptive components. So again, if you Google that, we'll find a whole plethora of information. And where you go and where you pick is going to be directly proportional to what you're going to get out of this exercise. And we're at the early stages, right? So these adaptive components are better managed in a file that's separate from the project environment. So let's move on to the project environment. You can build your forms directly within your project environment using the in-place massing tools, which we used. When walls are constructed through the in-place tool, the conceptual design environment does not have 3D reference planes and 3D levels. Again, we talked about the differences, the subtle differences between creating families in the family editor and in the in-place massing editor. And walls are a system. And you can't load in a wall from a family file, RFA. You can duplicate a wall from an existing system within the project and then create wall iterations based on the fundamentals of walls, basic walls, and then augment those walls to a new system style, if you will, a system type of wall. Now, so make note that it doesn't have 3D reference planes and 3D levels. Essentially, to create a complex curtain wall within the project environment, you follow these simple steps. Well, first of all, let me close out this louver family, or we're going to get confused. So now we have our basic 3 small rooms, if you will, or 3 small sandwiches, 3 small pockets, 3 small envelopes. Create an in-place mass in the project environment. Divide the surface. Apply a surface pattern. Replace the surface pattern with a pattern-based curtain panel family. Now that's in the project environment. Now let's do just that if we can. Actually, it kind of has some steps after this, and it basically doesn't really go into the steps of exactly how to do it, but we can do that. We can do that without knowing how to do it, because this software platform is so intuitive. So let me move on to the second paragraph in this exercise. Conceptual design environment. You create your curtain wall designs in the Revit Conceptual Design Environment, CDE, which is a type of family editor. These forms reside outside the project environment. You can then reference these massing families into a project environment, allowing you to explore contextual relationships within the building form. To create a complex curtain wall within the conceptual design environment, you're going to follow these simple steps. Build a new conceptual mass in the family editor. Divide the surface, apply a surface pattern, replace the surface pattern with a pattern-based curtain panel family loaded into your project. So it's basically the same series of steps, with the 5th step of loading it into the project. You start by designing a conceptual form that will represent the shape and form of the surface of the curtain wall. You are then able to subdivide the surface of this form using a grid system. referred to as the UV grid. A UVW coordinate system is used to plot location across the surface, as surfaces are not always planar, flat. This grid system automatically adjusts following the natural contours of a non-planar surface or form. The UV grid is then used as a guide for applying a pattern to the surface. You can investigate how you might panelize the surface to make it constructible by applying a geometric pattern to it. This pattern provides a basic graphic representation of how the panel may look. These graphic patterns can then be replaced with parametric components that automatically conform to the divided surface. That's a lot. Thank God for computers. But there are folks who can do this with a pencil. The beauty of it is that all of this is conveyed with a pencil. It has been. Colored pencils and chalk and paint, pastels, charcoal, burnt sticks. Let's take a look at the basic tools that allow us to divide the surface to a conceptual form. Start by opening the C13 square panel artifact from this book's webpage. This file represents a simple contextual shape for a curtain wall design. This form was constructed by drawing two curves at varying reference levels, and then a surface was generated between them. Select the form and then click Divide Surface in the contextual tab in the ribbon. This will divide the surface of the form, and you will see a horizontal and vertical grids displayed as this is the UV grid. You can control the display of the UV grid when it is selected. To modify the display, click the U grid or V grid button in the UV grids at intersects panel on the Modify Divide Surface tab of the ribbon. Okay, so now it wants us to use the family editor to start, but it really says to create it in the project environment to start. So let's just take it slow. If we're in architecture and we go to component, we go to model in place, you'll see that we can create a mass. We can create a wall, create an in-place mass in the project environment. Divide the surface, an in-place mass in the project environment. And by default, masses are the visibility graphics are shut off. Well, an in-place mass. Again, if we were to create a rectangle and just draw a rectangle, and create a form out of it, and then divide the surface if we got to a better view, and then divide the surface, U grid, V grid. So, if you look, the surface representation displays the original surface nodes or grid lines. Control the visibility of the surface pattern and component. Click the panel arrow. Okay. So now, before we get ahead of ourselves, notice that the U grid is selected, divides the selected surface with grid lines in the U direction. Click U grid to display or hide divisions. These grid lines are also referred to as UV lines, isoparametric lines, or contour lines. To apply a pattern to the surface, choose a pattern from the type selector. Well, it's already highlighted for us. And if we look in the options bar, modify divide surface within the context of invoking the massing tool and drawing a primitive geometric shape on a 2D plane, and then extruding that plane into the Z direction to give it depth, we opened an options parameter within the context of that command to adjust the parameters of the UV grid, the UV parameters. As you can see, the U grid number is 12, and there is no distance radio button checked to constrain that distance to 1/2 of an inch. But the V grid is also divided up by a number parameter that will constrain that, as does the U grid. But the distance parameter isn't constrained. There's no label on it because we can add parameters. So let's just again, take a slow look. The V-grid divides the selected surface with grid lines in the V direction. Click V-grid to display or hide divisions in this direction. These grid lines are also referred to as UV lines, isoparametric lines, or contour lines. To apply a pattern to a surface, choose the pattern from the type selector. Well, isn't that great? No pattern. Right? No pattern. Well, let's look at the patterns. We have half step, third step, no pattern, arrows, hexagon, octagon, rotate, rectangle, checkerboard, rhomboid, checkerboard, triangle flat, triangle checkerboard bent, triangle checkerboard flat, triangle step, zigzag. So again, these patterns are going to help us create unique and customizable curtain walls. So again, the first paragraph says how we can model it in place, and the second is within the conceptual design environment, or in the family environment, as a manufacturer would most likely do, because then the family will be uploadable from their website, so they could save us a lot of trouble in doing it ourselves, or get a job in the manufacturing sector. So create an in-place family in the project environment, in-place mass in the project environment. Divide the surface. Now, the surface pattern component. Let's take a look at this. Pattern displays the pattern lines and pattern fill applied to the selected surface. To control the visibility of the surface pattern and component, click the panel arrow. Well, let's take a look. Surface representation. Surface. Original surface. Nodes, UV grids, and intersect lines, which is what is selected. Style material, which is not selected. Pattern. Component. So you can see there are 3 tabs within the dialog box that allow us to further augment the design parameters of this wall, curtain wall, or concept. So click to select, tab for alternates. Well, I could select form element surface to divide up into a UV grid pattern, but there's absolutely no reason why I can't do it on any surface of this mass. I'm on the right side surface. I'm on the top. I'm on the edge. So I'm on the surface. Boom. Well, if you look, I selected the surface, divide the surface. So select it first. And as you can see, there are 12 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now that's not too hard to understand. Right now, intersects. Divides the surface using intersecting planes selected from the drawing area. Click on planes such as levels and reference planes and or lines drawn on reference planes to intersect the surface. To apply a pattern to the surface, select the divided surface and then select a pattern from the type selected to turn off intersects. Click intersects again to launch the intersects editor and select planes or lines to turn them off. Click finish to confirm. Divide the surface using intersecting planes from a list. Select intersecting planes such as levels or reference planes from the list. This list does not include unnamed references such as curves drawn or reference planes. To apply a pattern to the surface, select a pattern from the type selector to turn off intersects. All right, so we're going to get to that. So again, we've been able to do this with the divided surface with no pattern. So the surface is divided. And all it is a mass. That's all it is. It's nothing more than a mass. It has gross surface area volume, but doesn't have many parameters to it. We didn't add anything that's going to allow us to change these divisions unless we edit it in place. And then we would, of course, then have the option to change the UV grid pattern. So I'm going to hold that for a second, and then I'm going to come over here and I'm going to get it to a grab a pattern. I'm going to throw that pattern on there. And as you can see, again, the UV pattern, the UV grid still applies. The UV grid still applies. I can go over here. Let's divide that number in half. Now let's take a look at what effect that had. And see if it had any effect. And as you can see, it did. So that's not a very aesthetically pleasing pattern. There's a bit more to this. All right, so that's doing it in place. Replace the surface pattern with a pattern-based curtain panel family. Well, if you look at these are families. If I want to edit type, take a look. System family, arrows, system family, half step. All of these patterns are families. Now notice you can't load any right off the bat. But fret not, because this gets so much more complex. So if you're eager, follow along. If not, then don't. So let's just, now let's take a look. Displays the original surface nodes or grid lines. Displays the pattern lines and pattern. Applied. Surface nodes or grid lines with a pattern. Now remember, this has a surface, right? It's a divided surface. So, again, that surface may consist of a material. So again, if we look at this, the surface is being overridden by the pattern. The pattern doesn't have a material assigned to it. We can, and again, I will, you know me, I want to go into photorealism. You know me, I want to get right into the photorealism aspect of it. And you gotta be careful. Because you want to get it up there under the lights in a realistic virtual reality world just to look at it. And I'm just as guilty as the next one. You really want to render. You really want to render at the end of the day, right? Now component, if you can see, pattern component is grayed out. We haven't selected a pattern. We can't select a pattern component because we applied a surface to it. A surface pattern. Oh, I'm sorry, a pattern. And even its own surface is being overridden by that pattern. So let's just hold that thought, because again, if we just select this ellipsis, or we could create a pattern fill material parameter, right? So that we have this option within the properties of these patterns, one after the other. Or we could do it the old-fashioned, not the old-fashioned way, or we just apply it to this particular instance. And as you can see, all sorts of, whatever Cornier, you see even Cornier has their own surface textures and material patterns, material textures, if you will, materials embedded into this project template. So, as you can see, we have at our disposal whatever material loaded into this template. Let's just hold that thought, and let's just hit OK. Let's just finish the mass, and just cancel for a second. All right, so that is that, and now it is still a mass. It's not a wall. It's a mass, not a wall. Which is, it limits our ability to do things, and it enhances our ability to do things. Because it wasn't, this mass could have been a whole building, and then we could have went that route. So we've done it within the project environment, utilizing the steps that they told us. Now let's use it using the CDE, the Conceptual Design Environment. Build a new conceptual mass in the family editor. So File, New, Family, conceptual mass. File, New, opens a template for creating a conceptual massing model. Now, mass. So let's use a conceptual mass, and it's an RFA. As you can see, this two Revit sessions really going on at once here. We got the level 1 curtain wall custom project, and now you have Family 88. which is just the next number in sequence. And as you can see, there's a difference between the project browser and the family editor project browser. Because the family editor is a project, but again, it's only if it's a multi-floor family, it will have more floors, more levels. But if it's a conceptualization, it's going to have the basics right out of the box. And that consists of a floor plan or a reference level usually. And that's what's usually called when you create a new family, a reference level. And 3D views and elevations. Because if I was to do that again, you'll see the difference between the two. Now, the family editor is closed. Let's go to File, New, Family. You'll see it's picked the same thing. If I just pick a generic model, adaptive, generic model. If I can find it, that's the problem with looking at it in this generic model. It's always last in line, right? Now take a look here. You'll notice instead of it being floor 1, it's a reference level. And this is where the base point comes in. Remember, the insertion point. And if anyone's done any AutoCAD work to understand, it's where you grip it when you put it in. It's where you grip it, or you're holding it with your fingers. If you're holding it, if I'm holding this profile from this corner, when I put it in, it's going to be placed in that corner, and its offset is going to be dictated by that reference line, any of its offset parameters. And even when you extrude it. So, smoker's cough. All right, so just understand that. So we're in a different environment now. We're in the family editor environment. Build a new conceptual mass in the family editor. We close this, front, view 1. Look how many views open up just when you open up the family view. I didn't do anything, so it didn't ask me to save it. File, New, Family, Conceptual. As you see, there's no conceptual. Conceptual mass. And there it is. I apologize. Now, we get level 1, we don't get reference level. Okay, just so we see the difference between the two. And it was the same, it was almost the same as in opening or creating a new conceptual mass. This is that template. Build a new conceptual mass in the family editor. Okay, well, it's the same concept. If we go to level 1, that's the 3D view for the project. That's the 3D view for the conceptual mass. If we're in level 1, and we do the same thing, and we draw that rectangle, and we create a form out of it, a solid form. And then we look at it in 3D, and we divide the surface settings. And this is where the UV grid comes in. It hasn't popped up yet, but it'll pop up. If we divide the surface by just hitting it, the UV grid option bar will pop up. And we have the same ability to divide it up. Now look at the surface that was picked. The surface that we picked was already the top picked. The surface was picked. So now we divide the top surface, that edge, this edge, this face. And don't forget that face. And don't forget that face. And that face divides surface. That face divides surface. So you can see any surface. Tab, 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 tab. Come on. That surface we can divide. And then we go back to the isometric view and take a look. CA. We divided this thing all sorts of ways. Right? All sorts of ways. Okay, so again, lots of things we can do with these masses once we have them in place. And if you pick on a surface, you'll see grips come up. You could do all sorts of things. Even by picking on an edge, you'll get a grip. Right? Now, notice how you could really start to do some funky things with your curtain wall systems by just grabbing an edge. Right? Just grabbing an edge. Just like we discussed in modeling and massing, you can see there are ways in which you could start to really customize your conceptual mass. All right, so again, I'm getting way ahead of ourselves, way ahead of myself with that. So we could also apply a surface, right? We could apply a surface. It's a rectangular checkerboard. We could apply a surface, arrows. But now notice how arrows is tough to see it in. Arrows is tough to see. Let me give something that'll give it a little more. How it uses the surface to delineate the pattern. So if we look here, 1, 2, 3. There are 3, I should say 6 apexes. There's an apex here, there's an apex here, or vertice. A vertice here, a vertice here, and vertice here. Because of the distance of the wall, and that's what is going to define the hexagon pattern. That's what the hexagon pattern is conforming to the fixed number of UV grid divisions. As you can see, it's pulling that parameter from the parameter we built into it. So now, for aesthetic reasons, I'm just going to mess around through here so that you get a better idea of how that holds true. So if I change this number, go to the pattern, you'll see that the pattern takes control of that. Now, let's double check that math for a second. Well, I changed, not 21. Actually, it's directly proportional to it. So why do I keep putting it at 21? Silly rabbit. 12. Must be the bipolar. Now watch, when I change in the options parameter, it's linked into the number. The V-grid links into the pattern of the checkerboard layout. And grid rotation, we can change that, just like we could do with anything else, right? Let's see. I didn't get it. 45, let's change it. Tab. Sure. All right, so as you can see, again, for painting purposes, you want to paint it this way. Well, that's one way of conveying your intent for this pattern. So then we would just load it into the project and close it, right? Family 90, load it into the project and close it. Now notice where it goes. It goes right into the Revit tutorial exercises. It really should go into your family library. But I'll put it in here for now because I'm lazy today. I'm going to save that family in there. It's loaded into the project. And sure enough, well, there's family 90. I'll get it out of the way and pull it back here. But it's still, it's not mass, it's a family, right? It's a family. There's certain parameters, but not many. We didn't add that many parameters to it. Okay, so let's, stop there for a second. Let's read this a little forward. You start by designing a conceptual form that will represent the shape and form of the surface of the curtain wall. You are then able to subdivide the surface of this form using a grid system referred to as UV grid. A UVW coordinate system is used to plot location across the surface. As surfaces are not always planar, the grid system automatically adjusts, following the natural contours of a non-planar surface or form. The UV grid is then used as a guide for applying a pattern to the surface. You can investigate how you might panelize the surface to make it constructible by applying a geometric pattern to it. This pattern provides a basic graphic representation of how a panel may look. These graphic patterns can then be replaced with parametric components that automatically conform to the divided surface. It gets worse. Dividing the surface, let's look at the basic tools that will allow you to divide a surface of a conceptual form. Start by opening C13 square panel RFA from this book's webpage. So let's go back to where we're still in the project. I'll leave the project open, being that we're working with families, and I'm going to open a family. I'm going to open a curtain wall family that I believe would be here by panel. Let's see here, did I get it right? No, it's hold on. It's gonna be, let's see what it's gonna be. Now remember, you can't open a wall family, right? So, remember, it said, excuse me, this is an exercise file. So it's in the downloadable directory. You can't load a wall family. This isn't a wall family. This is a panel family. Let's take a look at it. And again, I live in the worst part of town. It's like 10 pounds of shit in a 5-pound box. All right, so let's take a look at this. This file represents a simple conceptual sheet. They start doing this at like 4 o'clock in the morning. And half of them are immigrants. They just have no ethics, morals, standards, values. And they come over here and they get the freedom, life O'Reilly. Don't get me started. Lately, I've been overwhelmed. They're coming at us. Let's take a look at the basic tools. I'm not anti-immigrant. I do believe in immigration reform because I'm telling you, they're coming here, they're coming over here on OPEC money. They owe money. And it shows up in all sorts of forms and it wants to talk about mathematics. And all it wants to do is have carte blanche to park anywhere it wants. And then they call the cops if you park two inches into their driveway. A man's homeless is canceled. Hey, Faye, don't get me started. Listen, I have an opinion on that. Dividing the surface. Start by opening C13 square panel. This file represents a simple conceptual shape for a curtain wall design. The form was constructed by drawing 2 curves at varying reference levels, and then a surface was generated between them. So we click on it. If we zoom in and click on it, it's not much. It's a form. Right? It's a solid form. A mass. We created this family from a mass. And then we haven't divided the surface yet, but again, it was created by making 2 curved lines and then creating a solid form out of it by picking both lines. Right? We talked about that. We talked about how, well, the family editor, when it's selected, you can create many shapes. And again, you can create many shapes. Right? You can create a reference plane, draw one on top, and then connect the 2 together. So I'm not going to get into we've done this already. I'm not going to get into it yet. We're going to have to do it all our lives, but one thing at a time. I don't know how many garbage trucks go up this block, but it seems like today it must have been 5 in a row, one after the other. This is the loudest neighborhood in the world, and I got my windows open. It's throwing damn forms. But I heard it's supposed to be humid, and we had some thunderstorms today. Okay, so we open the square panel. I'm off the tangent with my temper. And we see that we have a conceptual shape for a curtain wall design. The form was constructed by drawing 2 curves at varying reference levels, and then the surface was generated between them. Okay, now I'm not going to go into how it was drawn. I just know how it was. We can do it again if we have to. Select the form, and then click Divide Surface. Same thing comes up based on its defaults. On the contextual tab in the ribbon, this will divide the surface of the form, and you will see horizontal and vertical grids displayed. This is the UV grid. You can control the display of the UV grid when it is selected. To modify the display, click the UV grid, the U grid or the V grid button in the UV grids, and intersects panel on the Modify. Divide Surfaces tab in the ribbon. Modify, Divide Surfaces tab in the ribbon. Okay. Pause that. Yeah, there. Click it. This is considered the Modify Divide Surface tab. This is the grids and intersects panel of the ribbon. With the surface selected, make sure the U-grid and V-grid icons are highlighted in the contextual tab of the ribbon. The options parameter are highlighted in the contextual tab. Yes, highlighted here in the contextual tab. You have to know the words. Notice how the options bar provides a number of settings for you to modify the divided surface, and we talked about that. You can control the U-grid and V-grid by a number or with a specified distance. If you select a number option, you can enter a number of divisions that will distribute evenly across the surface, just like the mulligans. Just like the mulligans. Select distance, which will allow you to enter a specific absolute distance between grids across the divided surface. You're going to have to do more math. Under the distance setting, there's a drop-down menu that allows you to specify a maximum or minimum distance value. These are similar to the constraints described earlier in this chapter for basic curtain walls. Make sure the surface is divided by a number with a U-grid of 10 and V-grid of 10. So once it's divided with a number of 10 and 10. Double check it. It didn't accept it. 10. 10. No, it's stuck at 12 because it already did it. So I do it in the properties parameter. 10. 10. Apply. Yeah. So it's 10 by 10. Its UV grid is 10 by 10. It's starting to look like an antenna. Alright, so make sure it's set to 10 by 10. With the UV grid selected, you will see a 3D X, Y, and Z axis arrow. You will see a 3D control, an X, Y, and Z axis arrows. And an icon appears in the center of the surface. Click the icon to enable the Configure UV Grid Layout command. Isn't that a parabola? Oh boy. It gets so much more complicated. The display will change, and you can now apply specific settings to control the UV grid even further. Now again, if you look, U0, and distance 19'9¼ and it says number 10. That's the number of divisions. Set number of U-grid, you can actually set them here. You can set the distance there. But notice that there is an angle parameter in the V direction, right? In the V direction. And you would think X, Y, Z, but now we're going to add a V parameter, the V direction. And again, the UV coordinate system. Right, the UVW. It's, I hate to be the bearer of bad news, but the UVW mapping is a mathematical technique for coordinating, for coordinate mapping. In computer graphics, it is most commonly maps to map, in contrast to UV mapping, which maps to. That's very odd. Like the standard Cartesian coordinate system, has 3 dimensions. The third dimension allows texture maps to wrap in complex ways onto irregular surfaces. This one is pretty funny. The UVW mapping is a mathematical technique for coordinate mapping, period. In computer graphics, it most commonly maps to map, in contrast to UV mapping, which maps to, period. The UVW mapping is suitable for painting an object's surface based on a solid texture. So Wiki, again, I hate to get into the Pixar aspect of this, but it's universal. It's universal. Most material maps are 2D plane assigned to a 3D surface. Consequently, the coordinate system used to describe the placement and transformation of maps is different from the X, Y, and Z axis coordinates used in 3D space. Specifically, mapping coordinates use the letters UV and W, the 3 letters preceding X, Y, and Z in the alphabet. The UV and W coordinates parallel to the relative directions of X, Y, and Z coordinates. Parallel the relative directions. If you look at a 2D map image, U is the equivalent of X and represents the horizontal direction of the map. V is the equivalent of Y and represents the vertical direction of the map. W is the equivalent of Z and represents the directions perpendicular to the UV plane of the map. You might question why you need a depth coordinate like W for a 2D plane. One reason is because it's sometimes useful to be able to flip the orientation of the map relative to its geometry. To do this, you need the third coordinate. The W coordinate also has a meaning for three-dimensional procedural materials. See also unwrap UV modifier and UV map modifier. Well, you don't really need to be a wizard to know that you need to contrast and compare colors, right? Contrast and compare colors. Boy, oh boy. I hate to be the bearer of bad news. I really do. But it gets a bit more complicated. I told you that this is the study of space. Architecture is the study of space. Again, I'm not going up into space. Okay, I'll watch it on TV. But you can see exactly what it says. It's coincident with the that's why I planned in a Cartesian coordinate system. It's coincident to it. Okay? Lots of good examples that'll give you the generalization of what you're looking for. Now, again, pixelization plays a huge part in this. Pixelization, contrast colors. Now you can see this is for propeller heads. This is definitely for propeller heads, right? And if anyone's into animation, you don't really need much to know that if you take a pencil, and on each one of these small little dog ears, you draw a ball. Then you draw the ball a little further away from the original ball. Eventually, when you start flipping through the pages, you'll see an illusion, a deception. You'll see the UVW coordinate system. You'll see it. And you don't have to go up to a rocket to figure it out. Okay? I'm just trying to put it in simple terms. Because, again, it's all this math. And you can really get yourself, lost. Your centroid, your moment of inertia. Whoa. Rocket man, right? You know? We're talking about the study of space. So that's where Revit is just a really powerful tool. It's a really powerful tool, and it's going to open doors for you, and it has changed more the people that are using it than anything. It's the change within an organization of the folks that use it. Because the sky's the limit. The sky's the limit. And as you can see, computer animation has just gone well beyond the realms. So look what it does to the box office. Just look what it draws into the box. Again, I had my Trolls cake. They released it all at once. I had my Trolls cake. And I'll be honest with you, again, as a dad, you know, I was amazed with animation. Even as a child, I always have been. Always have been. But when you become a parent, those themes are just killers, right? You watch those kids, Disney, Pixar movies, and it's the theme that gets you. And that's the hard thing. Those films can convey a theme that really tugs on the heartstrings. And that's your job. That's your job. What was the word? Again, it's, there's a word I wanted to stress when it comes to conveying. And it's not ambiance. It's ambiance. It's not ambiance. It's not a feeling. It's more along the lines of an environment and a theme. And it's not coming to focus. But I'm a patient man. And again, this is a study of adaptive behaviors. And again, mood, right? You have to convey a mood to a certain extent. And that can be a powerful thing. If you can program somebody, that's a very powerful thing. And it comes with lots of responsibility. And if we're in the process of dividing triangles up, you realize that what it really is advertising. And this responsibility you have to have, right? So, now that we have been able to take a quick peek into the deeper aspect of this radar gun, you'll see that we have the ability to alter the rotation of the grid. The UV grid belt and the justification of the UV grids at the surface borders. These grid configuration parameters can also be found and modified in the properties palette. In the properties palette, set the U-grid rotation value to 45 degrees and the V-grid rotation value to 45 degrees and then apply. So, U, 45, tab, 45, tab, click outside of the properties palette, or don't, and then you miss it. This is a very tricky box sometimes. You gotta get in there. Well, first of all, you have to have your numbers logged on. 45, get in there. 45, tab, get out of the box. You can hover around and it'll do it, like you hit apply. It's that constant electromagnetic wave that allows it to just do it, stream right live. So again, we talked about, still hit that, take a look at the actual UV grid, get out of there and see with how we can manipulate it. Now I'm not gonna, I guess you have constrained. Well, I don't want to mess around with it. Okay, so let's just keep that grid selected. And notice that, double check, 45, 45. Hit apply. Notice how the modified values are updated in the 3D view with the configure UV grid layout command activated. In the configure UV grid layout mode, you will see a number of controls, all of which relate to parameters you can also access in the properties palette. The arrow across the middle of the grid is the grid justification marker. You can drag it to any side or corner or the center of the grid, which will adjust the value of the justification property of both U and V grids. Well, drag to change form. Press the spacebar to toggle. Well, that's not very intuitive. I don't think that's what it meant. It meant that in the properties palette, in the configure UV grid layout mode. In the configure UV grid layout mode, well, we haven't yet, but let's take a look. In the configure UV grid layout mode, which either is in the properties palette after you create it or in the context of creating it. So let's first discern whether or not the former was the case. Let's see. A number of controls. The arrow cross in the middle of the grid. The arrow cross. Well, that looks like an arrow cross. And that's not it. That's not it. So again, I'm going to take a look up here and see. I don't see the arrow cross. Again, if that's the arrow cross, then within the context, I can't change. There it is. In the layout, see, that's the word. In the configure UV grid layout, which is the button that appears, you'll see the cross. So, Southern Cross. Boy, I told you, I'll sprinkle a little theology. You will see a number of controls, all of which relate to the parameters you can also access in the properties palette. The arrow cross. Now, if you see, once we invoke that layout command, we have a few more properties within the properties palette. Like if I got out of there and selected the surface, you'll see that there's some properties associated with it. But it's not until you go into the layout mode, you'll see that the divided surface itself has properties that you can control. Belt measurement, which is rather bad. It sounds like a lot of fun to me. I love belts. As a matter of fact, my son Corey has a Ducati, and if he doesn't get that timing cover, that timing belt cover, he's gonna have a lot of problems. And he said he was gonna take it to CATA to get it ordered. I don't know what he's doing, but he better get it fixed. And he's one of the main reasons why, you know, I am worried sick, because my kids, unfortunately, I think it may have been just due to their adaptive behavior. But we've been rushed so much that, you know, they all had to go out and buy rice burners, cross rockets. Anyway, so as you can see, the grid justification marker. Grid justification marker. We can drag it to any side or corner of this or the center of the grid, which also adjusts the value of the justification property of both both U and V grids. So if I was to drag it over there, I actually rotated it. If I was to cancel, get into layout mode, it doesn't necessarily snap, but it does. I just lost my right arrow, and now I got it back. Let's bring it there, and I don't see any change. Off the bat, I don't see any change. Let me just take a look back at it and see if indeed did it move. And no, it went back to stay. Hold on a second, I wanted to also point something else out to you. My computer's running a little slow. That's a reference plane. And if we go to the level 1 of this, shoot, if we go back into the family, we go to level 1 of the family. I want to make sure there was no floors. As you see, this isn't a straight up square. It's more of a fan brush.
Funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
That was adaptive to it before it was not. All right, so again, if we go back into the layout mode, and if we take a look at what we can do with these grips, pattern, curtain, system grid, layout, shape, handle.
Funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
Measurement with a V grid. There's an adjustment that's made, and what it's affecting. You see, its distance is only affected, not the number. The number's holding true at 10. Because we set it by number, not by distance. But if we set this distance, this would affect the U portion of the grid, the U grid. Notice how the belt measurement, the V grid, notice how the belt measurement for the other grip didn't change. For the U grid, I change it now, it changed. So the belt.
Funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
Partitions. If you set it to distance, and then you can manipulate the distance to affect your grid. Now.
We hope you've enjoyed our programming and that you'll rejoin us tomorrow evening when your public television station in New Orleans returns to the air. WIAS-TV has been broadcasting from its studios just west of City Park at 916 Navarre Avenue on facilities made available to it through the cooperation of the governing authority, Delgado Junior College. The WIAS visual transmitter has been operating on an assigned frequency of 205.25 megahertz at an effective radiated power of 126,000 watts. Our oral transmitter has been operating on an assigned frequency of 209.75 megahertz at an effective radiated power of 19,100 watts. We are linked to our transmitter, which is located near Chalmette off Paris Road, by a microwave station KLB 84, power 1.5 watts, frequency 6912.5 megahertz. WIAS is licensed to the Greater New Orleans Educational Television Foundation by authority of the Federal Communications Commission, and is an independent and non-profit organization serving the people of Southeast Louisiana. We now leave the air wishing all our viewers a good night and a better tomorrow.
These belts are important. Okay, so the surface.
watching WBGU-TV in Bowling Green, Ohio. We are a non-commercial public television station owned and operated by Bowling Green State University. WBGU-TV is authorized by the Federal Communications Commission to broadcast on Channel 27 and is allocated to Bowling Green, Ohio. Our transmitter is located on Belmore Road near Deschler, Ohio. Our studio and offices are located at 245 Troop Street in Bowling Green. Channel 27's studio to transmitter links, WOJ49 and WBE778 and WBGU-TV are licensed to Bowling Green State University. WBGU-TV provides educational television programs in cooperation with the Northwest Ohio Educational Technology Foundation, a nonprofit corporation created to serve the instructional needs of Northwest Ohio's elementary and secondary schools. Channel 27 provides this service during regular school hours. WBGU-TV's evening schedule provides educational, cultural, and entertainment programs 7 days a week. We are proud to be a part of Northwest Ohio and are committed to providing a valuable service to all of its residents. In line with this commitment, we invite your comments regarding our programming. Please send those comments to WBGU-TV, Attention Program Director, 245 Troop Street, Bowling Green, Ohio, 43403.
Austin City Limits is made possible by public television stations, with additional funding provided by
I don't know that nonprofit.
the people at Budweiser, brewing the world's largest selling beer.
A lot of times when you'll fling anything onto coffee cup or whatever, you're all right? So
Austin City Limits is brought to you locally by the Luthol Group, which says your best investment is public television. And by the Pottery Place in historic Red Wing, offering factory outlets, specialty shops, and restaurants.
one of those continuous sprays.
You are watching KTCA-TV, St. Paul, Minneapolis, Channel 2.
I don't know about nonprofit.
You turn us on and we love it. Great new shows you'll love to see. You'll turn us on and you'll love it. TV worth watching, public TV.
As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA-TV is owned and operated by Twin Cities Public Television Incorporated and operates on a federal
I don't know about nonprofit.
460 megahertz. Programming originates from the KTCA-TV studios, 1640 Como Avenue, St. Paul, and is fed via microwave link KAS-23 to our transmitting site in Shoreview. If you'd like to comment on our broadcast program schedule or operations, please write KTCA-TV, 1640 Como Avenue, St. Paul, Minnesota 55108, or call 646-4611 during regular business hours. We now conclude our scheduled broadcast for today. Thank you for joining us. Be sure to be with us again tomorrow. Good night.
You turn us on and we love it. Great new shows you'll love to see. You'll turn us on and you'll love it. TV worth watching, public TV.
Public TV, we bring you the music. You can really know the score.
We're your ticket to front row center. Premiere performances galore.
Public TV is family viewing. We're as big as all outdoors.
There's information and education, the kind your kids love to explore. You turn us on and we love it. Great new shows you'll love to see. You'll turn us on and you'll love it. TV worth watching. Public TV.
I'm just going to dry around this a little bit just to show you
You are watching KTCA TV, St. Paul, Minneapolis, Channel 2. As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA TV is owned and operated by Twin Cities Public Television, Incorporated, and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA TV studios at 1640 Como Avenue, St. Paul, and is fed via microwave link KAS-23 to our transmitting site in Shoreview. If you'd like to comment on our broadcast program schedule or operations, please write KTCA TV, 1640 Como Avenue, St. Paul, Minnesota, 55108, or call 646-4611 during regular business hours. We now conclude our scheduled broadcasts for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
Off, then it's just that regular gray again, or kind of dark. It's more of like a dark gray black probably. And the coolest part about this is
funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
But once that
We hope you've enjoyed our programming and that you'll rejoin us tomorrow evening when your public television station in New Orleans returns to the air. WIS-TV has been broadcasting from its studios just west of City Park at 916 Navarre Avenue on facilities made available to it through the cooperation of the governing authority, Delgado Junior College. The WIS visual transmitter has been operating on an assigned frequency of 205.25 megahertz at an effective radiated power of 126,000 watts. Our oral transmitter has been operating on an assigned frequency of 209.75 megahertz at an effective radiated power of 19,100 watts. We are linked to our transmitter, which is located near Chalmette off Paris Road, by a microwave station KLB 84, power 1.5 watts, frequency 6912.5 megahertz. WIS is licensed to the Greater New Orleans Educational Television Foundation by authority of the Federal Communications Commission, and is an independent and non-profit organization serving the people of Southeast Louisiana.
good to go there. Facebook, it's just water in the spray bottle, yes. Just water. Nothing special. Good to go there. And YouTube, let me turn the lights back on here. And flip around for you guys on YouTube.
Funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
We hope you've enjoyed our programming and that you'll rejoin us tomorrow evening when your public television station in New Orleans returns to the air. WIS-TV has been broadcasting from its studios just west of City Park at 916 Navarre Avenue on facilities made available to it through the cooperation of the governing authority, Delgado Junior College. The WIS visual transmitter has been operating on an assigned frequency of 205.25 megahertz at an effective radiated power of 126,000 watts. Our oral transmitter has been operating on an assigned frequency of 209.75 megahertz at an effective radiated power of 19,100 watts. We are linked to our transmitter, which is located near Chalmette off Paris Road, by a microwave station KLB 84, power 1.5 watts, frequency 6912.5 megahertz. WIS is licensed to the Greater New Orleans Educational Television Foundation by authority of the Federal Communications Commission, and is an independent and non-profit organization serving the people of Southeast Louisiana. We now leave the air wishing all our viewers a good night and a better tomorrow.
You are watching KTCA TV, St. Paul, Minneapolis, Channel 2. As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA TV is owned and operated by Twin Cities Public Television, Incorporated, and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA TV studios at 1640 Como Avenue, St. Paul, and is fed via microwave link KAS-23 to our transmitting site in Shoreview. If you'd like to comment on our broadcast program schedule or operations, please write KTCA TV, 1640 Como Avenue, St. Paul, Minnesota, 55108, or call 646-4611 during regular business hours. We now conclude our scheduled broadcasts for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
Watching WBGU-TV in Bowling Green, Ohio. We are a non-commercial public television station owned and operated by Bowling Green State University. WBGU-TV is authorized by the Federal Communications Commission to broadcast on Channel 27 and is allocated to Bowling Green, Ohio. Our transmitter is located on Belmore Road near Deschler, Ohio. Our studio and offices are located at 245 Troop Street in Bowling Green. Channel 27's studio to transmitter links, WOJ49 and WBE778 and WBGU-TV are licensed to Bowling Green State University. WBGU-TV provides educational television programs in cooperation with the Northwest Ohio Educational Technology Foundation, a nonprofit corporation created to serve the instructional needs of Northwest Ohio's elementary and secondary schools. Channel 27 provides this service during regular school hours. WBGU-TV's evening schedule provides educational, cultural, and entertainment programs 7 days a week. We are proud to be a part of Northwest Ohio and are committed to providing a valuable service to all of its residents. In line with this commitment, we invite your comments regarding our programming. Please send those comments to WBGU-TV, Attention Program Director, 245 Troop Street, Bowling Green, Ohio, 43403.
Blake 7 is brought to you locally by Comic City, purveyor of fine comic books, serving uptown Minneapolis since 1974.
You are watching KTCA TV, St. Paul, Minneapolis, Channel 2. As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA TV is owned and operated by Twin Cities Public Television, Incorporated, and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA TV studios at 172 East 4th Street, St. Paul, and is fed via microwave links WNEX 206 and KAS 23 to our transmitting site in Shoreview, Minnesota. If you would like to comment on our broadcast program schedule or operations, please write KTCA TV, 172 East 4th Street, St. Paul, Minnesota, 55101. Or call 222-1717 during regular business hours. We now conclude our scheduled broadcasts for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
Austin City Limits is made possible by public television stations, with additional funding provided by a special grant from the people at Budweiser, brewing the world's largest selling beer.
Austin City Limits is brought to you locally by the Lufil Group, which says your best investment is public television, and by the Pottery Place in historic Red Wing, offering factory outlets, specialty shops, and restaurants. You are watching KTCA TV, St. Paul, Minneapolis, Channel 2.
You turn us on and we love it. Great new shows you'll love to see. You'll turn us on and you'll love it. TV worth watching, public TV.
As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA TV is owned and operated by Twin Cities Public Television Incorporated and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA TV studios at 1640 Como Avenue, St. Paul, and is fed via microwave link KAS-23 to our transmitting site in Shoreview. If you'd like to comment on our broadcast program schedule or operations, please write KTCA TV, 1640 Como Avenue, St. Paul, Minnesota 55108, or call 646-4611 during regular business hours. We now conclude our scheduled broadcast for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
You turn us on and we love it. Great new shows you'll love to see. You'll turn us on and you'll love it. TV worth watching, public TV.
Public TV, we bring you the music. You can really know the score.
We're your ticket to front row center. Premiere performances galore.
Public TV is family viewing. We're as big as all outdoors.
There's information and education, the kind your kids love to explore. You turn us on and we love it. Great new shows you'll love to see. You'll turn us on and you'll love it. TV worth watching. Public TV.
Channel 2 will now leave the air until tomorrow morning. WLBZ TV, W04AK, translator on Channel 4, and W57AQ, translator on Channel 57, are owned and operated by WLBZ TV Incorporated, and operate on assigned carrier frequencies by the authority of the Federal Communications Commission. Our offices and studio are located at Television Center on Mount Hope Avenue in Bangor. Our transmitter is on Riders Peak in East Holden. Our translator, W04AK, is located on the Augusta Road in Winslow. Our translator, W57AQ, is located on Conant Hill in Medibems. The entire staff at Channel 2 wishes you a very pleasant good night.
Doctor Who is brought to you locally by The Unpainted Place, designers, builders, and retailers of natural wood furniture. You're watching KTCA TV, Channel 2, St. Paul, Minneapolis. As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA TV is owned and operated by the Twin Cities Public Television Corporation and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA TV studios at 1640 Como Avenue, St. Paul, and is fed via microwave link KAS-23 to our transmitting site in Shoreview. If you would like to comment on our broadcast program schedule or operations, please write KTCA TV, 1640 Como Avenue, St. Paul, Minnesota, 55108, or call 646-4611 during business hours. We now conclude our scheduled broadcasts for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
Give me a break. Weeknights at 6:30.
This is WCCB in Charlotte, North Carolina, signing off Channel 18. WCCB's transmitter is located at 2101 Newell Hickory Grove Road, 1 mile east of Newell, North Carolina, and operates on a frequency of 494 to 500 megahertz with a maximum authorized power of 2,100,000 watts effective radiated. Video and audio transmission between the studio and transmitter is by STL station KVF-29, located at One Television Place, Charlotte, North Carolina, and operates on a frequency of 7,000 to 7,025 megahertz. And now we wish you a very pleasant good night.
Alabama Public Television is your place for great fun that all the family can share. Top quality family and children's programs depend on your financial support. Become a contributing member now by sending your check for $25 or more to APT, Department A, Box 55803, Birmingham, Alabama 35255.
Alabama Public Television is great for families. My children grew up watching Sesame Street, Mr. Rogers' Neighborhood, and Reading Rainbow. They love the funny characters and cartoons. As a parent, I love the fact that the shows are educational and make learning fun for children. We hope you'll join our family in sending a contribution today.
Anne of Green Gables, a remarkable young girl whose imagination and red hair cause her no end of trouble. An orphan, taken in by an elderly brother and sister, she grows from an awkward girl to a mature young woman. Megan follows Colleen Dewhurst and Richard Farnsworth in Anne of Green Gables on WonderWorks.
Viewer-supported television, APT, Channel 10 in Birmingham.
This is the Alabama Public Television Network, owned by the state of Alabama and operated by the Alabama Educational Television Commission, headquartered in Birmingham. From 9 transmitter sites, we have served the state since 1955. WAIQ, Channel 26 in Montgomery. WBIQ, Channel 10 in Birmingham. WCIQ, Channel 7 atop Mount Cheaha. WDIQ, Channel 2 in Dozier. WEIQ, Channel 42 in Mobile. WFIQ, Channel 36 in Florence. WGIQ, Channel 43, Louisville, also serving Texasville. WHIQ, Channel 25 in Huntsville. And WIIQ, Channel 41 in Demopolis. Through public, corporate, and viewer support, we offer programming that entertains, stimulates, and informs. Watch with us. Television at its best.
Good morning. WREX-TV Channel 13 in Rockford, Illinois, now begins its broadcast day. WREX-TV transmits at an effective radiated power of 316,000 watts on a frequency of 210 to 216 megahertz. All programming broadcast by WREX-TV is intended for the private use of our audience and is protected by the copyright laws of the United States and cooperating nations. Any other use of the programs or charge for their use is prohibited without our express written permission. Some of the programs broadcast by WREX-TV have been recorded at an earlier time or date. WREX-TV is operated under license from the Federal Communications Commission by Quincy Newspapers Incorporated, with offices, studio, and transmitter located at Auburn and Meridian Roads in Rockford, Illinois. Welcome to another day. We hope it's a good one. We now come to the end of another day of programming at WREX-TV. All programs broadcast by WREX-TV are intended for the private use of our audience and are protected by copyright laws of the United States and cooperating nations. Any other use or any charge for use of these programs without our express written permission is prohibited. WREX-TV is operated by Quincy Newspapers Incorporated, with offices, studios, and transmitter located at Auburn and Meridian Roads in Rockford, Illinois. WREX-TV is licensed by the Federal Communications Commission to operate on a frequency of 210 to 216 megahertz and transmits at an effective radiated power of 316,000 watts. There's more information and great entertainment later this morning when we return to the air. Until then, all of us at WREX-TV wish you a very pleasant good night.
This is WYCC-TV Channel 20, Chicago. Channel 20 is owned and operated by the City Colleges of Chicago. The City Colleges are Malcolm X, Wright, Kennedy King, Truman, Olive Harvey, Daley, Washington, and Chicago Citywide. Channel 20 is transmitted from the top of the John Hancock Center. In closing, Channel 20 wishes you a good evening. Thank you for joining us.
This program was produced by KTCA, a Minnesota original.
You are watching KTCA TV, St. Paul, Minneapolis, Channel 2. As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA TV is owned and operated by Twin Cities Public Television, Incorporated, and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA TV studios at 172 East 4th Street, St. Paul, and is fed via microwave links WNEX 206 and KAS 23 to our transmitting site in Shoreview, Minnesota. If you would like to comment on our broadcast program schedule or operations, please write KTCA TV, 172 East 4th Street, St. Paul, Minnesota, 55101, or call 222-1717 during regular business hours. We now conclude our scheduled broadcasts for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
Funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
hope you've enjoyed our programming and that you'll rejoin us tomorrow evening when your public television station in New Orleans returns to the air. WIAS-TV has been broadcasting from its studios just west of City Park at 916 Navarre Avenue on facilities made available to it through the cooperation of the governing authority, Delgado Junior College. The WIAS visual transmitter has been operating on an assigned frequency of 205.25 megahertz at an effective radiated power of 126,000 watts. Our oral transmitter has been operating on an assigned frequency of 209.75 megahertz at an effective radiated power of 19,100 watts. We are linked to our transmitter, which is located near Chalmette off Paris Road, by a microwave station KLB 84, power 1.5 watts, frequency 6912.5 megahertz. WIAS is licensed to the Greater New Orleans Educational Television Foundation by authority of the Federal Communications Commission.
You are watching KTCA-TV, St. Paul, Minneapolis, Channel 2. As a community-supported, non-commercial public television station, KTCA serves the entire Twin Cities area with programming designed to inform, entertain, and educate. KTCA-TV is owned and operated by Twin Cities Public Television, Incorporated, and operates on a federally assigned frequency of 54 to 60 megahertz. Programming originates from the KTCA-TV studios at 1640 Como Avenue, St. Paul, and is fed via microwave link KAS-23 to our transmitting site in Shoreview. If you'd like to comment on our broadcast program schedule or operations, please write KTCA-TV, 1640 Como Avenue, St. Paul, Minnesota, 55108, or call 646-4611 during regular business hours. We now conclude our scheduled broadcasts for today. Thank you for joining us, and be sure to be with us again tomorrow. Good night.
Austin City Limits is made possible by public television stations, with additional funding provided by a special grant from the people at Budweiser, brewing the world's largest selling beer.
Austin City Limits is brought to you locally by the Luthol Group, which says your best investment is public television. and by the Pottery Place in historic Red Wing, offering
Funds for captioning this program were provided by the Bureau of Education for the Handicapped, U.S. Office of Education.
We hope you've enjoyed our programming and that you'll rejoin.
Phase 2 on Monday. One of these days I'm going to quit. One of these days. Anyway, I told you we're getting through creating complex curtain walls today. So, back to business. We got to get down to business. Brass tacks. Got it with a pickup on my receiver. I'm feeding it right back in. A recursive loop. Let me turn this down. This mic's very sensitive. As am I. I'm a sensitive guy. Okay, so we've talked about the UV grid and working within a conceptual design environment, as well as working within the project environment to invoke the model in place command and create a mass that we can base on replace with a surface pattern and a pattern-based curtain panel family. So the UVW coordinate system plays a big part in that, and how it is coplanar with the XYZ axis when it's coplanar. That doesn't always have to be the case. Each one of those vectors have about as much 360-degree rotation as the XYZ coordinate system, or the Cartesian coordinate system. Now, there's lots of coordinate systems, and anyone who's programmed GPS devices will tell you that. 60-degree rotation as the x-y. Z coordinate system, Cartesian coordinate system. So that's definitely going to get picked up. Anyone who's programmed. So the challenge with this, obviously, is the feedback. But when we divided that, if you remember, the last thing we did was we divided that UVW coordinate system into divisions of 10. Now, we all know there are 3 divisions of the 24-hour cycle, right? Day, night, and graveyard. Well, it looks like tonight it can't be the graveyard. It can't be the graveyard for me tonight. I've got a lot to do. Modeling floors, ceilings, and roofs is as complicated, if not more complicated. But one thing you'll get out of this session, or the series of sessions, is you'll start to see how the conceptual design plays so much more into it. And if you can take some of these lessons and apply them, you'll find that you weren't, not barking up the wrong tree, and you weren't misguided. You weren't misguided. Now, I want to find a passage that I wanted to reiterate to you, because I found it to be something that's so important. And inspiration is one thing, but you can get too caught up in a lot of that. Hysteresis in an electrical circuit is not good. Harmonics are not good for an electrical system. To a certain extent, if they're balanced, then that's something else. But what I wanted to find was that that one passage. I can't find it now. I'm going to look until I find it. It's more along the lines of what you're to expect. But I think that one passage is one of the most profound passages in the text. And I should have highlighted it. I did highlight a bunch, but I didn't highlight that one passage. Well, I'm sure I'll find it. Let me see if I could skim through again. I have time. Let me just go to the front here for a second. See if I could find this. Yeah, I'm sure I'll come across it eventually, but you remember what it was. What it stated was that this BIM, Building Information Modeling Endeavor, and the software platforms that utilize it, affect the culture of the company and the users of the software more than anything. More than anything else, this text, as you read through it and you start to study and do some research, it has more of an effect on a company's culture and more of an effect on an individual than it does on anything else. Not to mention the fact that it directly implies infrastructure in place. And that's what this thing does. And I've used so many synonyms as to what this tool actually is. But again, computer as a tool, a computer. Compute. And that goes for us as well. You know, malfunctions, malformations, all sorts of things in between. So, we set this V-grid on a 10 by 10 pattern. We rotated it 45 degrees. Now, we talked about the belts along the surface which form the distance between grids. Which the distance between grids are measured. Between grids. And that can be adjusted. So now, the UV grid can be modified directly or via the values in the properties palette. So I've got to stream the video, unfortunately, and fortunately. So, or there'll be lag, you know, just like that's why you put your screensaver on, right? So I'm going to keep me as thin as I can, and just check the, I gotta keep myself a little thick. I gotta bring myself into the picture. Uh-oh. No, that's not what I wanted to do. Oh no, what is this? No more errands. I can't do any more errands. I just got in. The parking's crazy. It's crazy around here, the parking. It's crazy around here. These kids, let me tell you, there's not enough time in the day. Oh, I keep hitting the transition stinger. Well, that's gonna have to play itself out. I like to play with a vacuum in the middle. This paper thin transparency that we got. Silly me. It's more silly than anything. Let me turn off this transition. Is this the one I set? I set this one too. Alright, so I don't know if we're going to get enough video, so I got to put myself in here a little bit. Hopefully that doesn't disturb you. But we got to get back to this. Right? We got to get back to this. This UV grid, this UVW grid. So as you saw in the previous exercise, the divide surface tool allows you to divide the surface of a form using the natural UVW grid of the surface. However, if you want to divide the surface with a customized grid pattern, buy some masks. You divide it by intersecting geometry. By using the intersect feature, you can divide the surfaces, well, the surface based on the following: intersecting levels, reference planes, and even lines drawn on a reference plane, a mixture of U or V grids and intersects. Let's take a look at an example based on our previous file, which will demonstrate how you can use a series of defined reference planes to divide a surface. Start by opening the file C13 Square Panel Intersects RFA from the Books Companion website. So I'm going to keep this open, this Square Panel RFA, and we don't have a project open. This is another family. Make sure, yes, we still have the project open. I take that back. Level 1 is level 1 for the Square Panel RFA we're working on. So I'm going to close that. I'm going to keep open a Square Panel RFA. Or do I want to do that? Let me skim ahead real quick. See if indeed we need to do it. You know, yeah, they want us to apply it here. Square Panel border, Square Panel pattern RFA, right? Yeah, well, yeah, they want us to open this right back up. So I have to keep this open. So I'm just going to open up another, and you have to keep your project browsers within perspective, or you're going to be working in a project browser from another project. So that you have a few projects open at once. I'm going to have the project and then 2 family files open at the same time. And that can be confusing to some people. That's why tiling of views is important, and we discussed that to a certain extent. So we're going to be looking for the Square Panel Intersects RFA, which isn't in the Imperial Library. It's wherever you downloaded your data files to. So if I go to the C13 directory and dig it up, Square Panel Intersects. Let's take a look at this. It's similar to the Square Panel, but as you can see, there are a few things going on here. And I can tell just by looking at it that there's a lot going on. We've got reference planes under here. These seem like all reference planes. That's a reference plane. That's a reference plane. I could have sworn I saw some lines. What is that? That is also a reference plane, but if you look at it from the front, isn't that unique? Isn't that unique? So we have this swept blend, if you will, this void, this arc void, that is indeed a form. It doesn't have any thickness, it doesn't have any material assigned to it, but it's a form, and it's a solid form. Now, let's follow along with the instructions. It says that we can intersect levels, reference planes, even lines drawn on a reference plane. Intersect them. To do what? If we take a step back, what would that do for us? What would dividing this surface of this form do for us? Well, you gotta go back and remember, spandrel, shadow box, spider fittings, complex curtain wall systems, mullions, curtain panels, curtain wall types, corner mullions, doors at curtain walls, walls in curtain walls, segments of mullions, customizing curtain grid segments, replacing panels and mullions, creating simple curtain walls, stacked walls, basic walls, modifying wall profiles, all these things. So, this tool holds true for not just curtain walls, just letting you know, it's patterns. But, to a certain extent, the structural aspect of it is what's going to make the difference as to whether or not you can apply some of these beautiful patterns to regular walls without them collapsing. So let's take a look at an example based on a previous file, which will demonstrate how you can use a series of defined reference planes to divide a surface. We open the Square Panel Intersects. Notice that a series of reference lines are now drawn in the X-plane. In the X-plane. You will use these reference lines to divide the surface of the form in the X-plane. Well, here's X, and here's a reference plane, but if we look at it in 3D, the series of reference planes they're talking about are these, 1, 2, 3, 4. This is the one in the front. That's a reference plane for the front. This is the front reference plane. If we hover around this and look at it so that we can see the ones drawn in the X, we'll see that this front reference plane, that's not what it's talking about. It's talking about a series of reference lines are now drawn in the X-plane. You will use these reference lines to divide the surface of the form. Select the surface and choose Divide Surface from the ribbon. Click the U-Grid tool on the ribbon to disable the display of U-Grids. So select the surface. Let's get it back in a orthographic view. Select the surface. Divide the surface. Click the U-Grid tool on the ribbon to disable the display of it. That highlight, that turns it off, that turns it on. The U-Grid is off. With the surface still selected, which it's not, divided surface it is, click the intersects button on the panel. On the ribbon, on the surface representation panel is the ribbon within the context of selecting the surface. The modify divided surface command pops up. Toolbar ribbon pops up. Contextual ribbon. I'm drilling that home. If you can speak in those terms, people can understand you when you're conveying this information to them over the phone if you're in tech support. With the surface still selected, click the intersects button on the ribbon. Select all reference planes in the X plane, and then click the finish icon in the intersects panel on the ribbon. So if you look at the status bar, pick splitting references, plural, for divided surface. Well, if we're going to pick them, I could do a selection box, and I can pick just these here. Now that one in the front, I don't want to grab. I want to grab these. Not that one. Not this one. This I don't believe is the one I want. That's the well, that is in the XY plane. That is that is in the XY plane. So that one's going to have to get included too. So if we look at this, you see this diagonal one is the one that's really throwing me off. This one, it exists in the XY plane. If you look at it, it exists in that diagonal line exists in the XY plane. So our best bet, and again, still, the status bar is telling us what to do. Our best bet is to grab this in an all-encompassing polygon and try to get just what's in the XY plane. Notice how it looks like we selected other things, but this is an all-encompassing box. So it's only becoming a highlight because those are the planes. And the misleading part about these planes is space can confuse you, and I'll tell you why. Because these reference planes behave just like Euclidean space planes. I don't know if anyone knows who Euclid is, E-U-C-L-I-D. But Euclid is a very interesting individual. And I'm just going to do this first, and then we're going to talk about Euclid if I can remember. Okay, hold that thought. Hold that thought. So with the surface still selected, click the intersects button, select all the reference planes in the X-plane, and then click the finish icon in the intersects panel on the ribbon. Not all intersecting references, levels, reference planes, or lines could be used to intersect the surface. Okay, well, we're going to take a look at that. This will divide the surface based on where the reference planes intersect the surface of the form. You could also select intersects list to choose named references such as levels or named reference planes instead of picking them in the model view. Okay, well, if we had them named, we could have picked them from a list. But let's see. Well, I could have sworn I got this one. I could have sworn I got this one, that one, this one, and this one. But I don't really see anything that's giving me the all's well here. Well, yeah, it kind of did. Yeah, if you look, these two reference planes, yeah, if you look at it, these two reference planes divided the surface here, and these two created these panels, or these divisions. These two created these divisions. This here, in the bottom reference plane, created the bottom divisions. But what it didn't do is, if you notice, this swept, this curve, this arc. That arc, if we go back and forth with it, you'll see that one arc kind of drew in right here, and it's part of the surface. It's part of the surface. Now, you remember there was an arc on the bottom and an arc on the top, and now there's an arc in the middle. Now, I selected this reference plane, this diagonal reference plane. So, just make a note of that. Go to the project browser, open the 3D view name, 3D view name 3D surface to review the results. Now, they don't have the arc, this lower arc. So, unless there was a reference plane up here that I didn't see, their divided surface only has this arc tangent intercept. So I want to undo that for a second. And I want to see here, because we selected, I caught this edge, is what I caught. I should have filtered it out. So if we go back and we select the surface, and we select intersects, and I just catch these, right here, and this one. Hold down Control, select these, and the diagonal one, not the edge of the arc, not the edge of the arc. Give me a second. All right, so, and then hit finish. And I got it again. I got this extra arc. In addition to this arc. And let's take a look at it from the front. I also got the V, the V grid in their pattern. The pattern they have, they don't show the V grid. They told us only to turn off the U grid. Now, I'm not going to say anything about that. I'm just going to let that be what it is. It told us to turn off the U grid and not the V grid in the UVW coordinate system. And I didn't turn off the V grid. And I got an extra loop. But in the surface is divided by intersecting planes and lines. And the pattern shown in the book doesn't show the vertical, the V grid, nor does it show the extra parabola or French curve. It's different. But the horizontal divisions are spot on. They're spot on. Now, okay, so applying patterns. Surface patterns allow you to quickly preview in a graphical manner how a panel will work across the surface of the form. Now, if you remember, we have these patterns here. The editing and adjustment to the design concept are quick because you are not working with complex geometry at this stage. Revit provides a number of predefined patterns that are available from the properties palette, and they can be applied to your divided surface. You will now apply a surface pattern to a form. Start by opening C13 square panel pattern. Square panel pattern, not square panel. Now we have to open square panel pattern. So let's open up square panel pattern. So now we've got 3 RFAs open and 1 project open. Just keep that in mind. So here is square panel pattern. Here is square panel intersects, and this is square panel. And then we have project 1 or project curtain wall custom RVT with that mass. So let's go back into square panel pattern. And notice that it must have been created with a conceptual mass. It's not a reference plane, it's a level 1. Now, surface patterns allow you to quickly preview in a graphical manner how a panel will work across the surface of the form. We talked about that. If we select it, the panel, we have patterns that we can grab. And now it's not going to let me. Let me grab the panel, and we divide surface, and then we'll get the patterns, right? If we divided the surface, with the surface still connected, selected, we'd be able to then rudimentary, coarsely analyze the surface. This is more of a what's the word they used? We're not working with complex geometry at this stage. So it's not, these predefined patterns aren't very complex patterns, is what I was trying to say. So let me undo that, and let's not skip ahead, because you know me. Okay, so with the UV grid on the form selected, it's on. You'll notice in the type selector that the default empty pattern named No Pattern is applied to the surface. Open the type selector and you will see that you can change, that you can apply one of any number of predefined patterns to the surface. And we've seen that. Experiment with the various predefined patterns and adjust the UV grid as required to play with the proportions of the patterns. Now, we did that. And if we could do it by the arrow key, it'll be a lot easier. Let's see if I can do it by the arrow key. If I keep my mouse out here, maybe, and do it by the arrow key, will they change automatically? Oh, of course not. I have to actually grab it. And that's octagon rotate. And you see how it'll actually, the cool thing about it is, you'll see void space. In order for it to keep it on a 12 by 12 ratio, it'll cut out the area that those octagons don't occupy. And if we look at the surface again, and we can, don't forget the belt surface, right? The belt surface. Change the belt surface. Select the surface again. Do a half step. And undo, 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 because I'm not going to miss the belt surface just yet. Let's double check that it's not moved. Okay. Actually, it is. I'm going to move that back. Double check the belt surface. Okay, it's good. It's synonymous. U, V, right? UVW. Okay, so click the rectangular checkerboard pattern. The rectangular checkerboard pattern. Rectangular checkerboard pattern. Experiment with the various predefined patterns and adjust the UV grids as required to play with the proportions of the patterns. Okay, well, if we divide it, well, let's look. 1, 2, 3, 4, 5, 6. Well, there are 6 black and there are 1, 2, 3, 4, 5, 6 white. Well, if I made this 24, right, what do you think's going to happen? You're going to get 12 and 12, right? And if I change this to 36, what do you think's going to happen? As you can see, the pattern can be adjusted with the UV grid. And again, angle 2, and I just like doing the angle. I like doing it because I just think it looks cool. It's a 15 degree. But now, again, that belt is something that plays a part, right? Doesn't this play a part? Move this belt. It's the measuring distance, but it doesn't seem to have much of an effect on it as of yet. And I think that has more to do with the profile that's coming up. So I'm not going to burden myself with that. Just make sure I have it set back, because I like to, like it says, mouse around. At any time, you can display both the underlying surface divisions and the pattern surface with the grid select. Click the surface button in the surface representation panel on the Modify Divide Surface tab. This display should give you a better understanding of the relationship between the pattern definition and the spacing of the surface divisions. So with the wall selected, the surface representation panel, surface, turn off the pattern, there's the surface, turn off the surface, there's the panel, turn on the pattern. Oops. So that's a toggle. We didn't get into this yet. And this is what we're getting to. And if you look down here, there's some more bells and whistles. Surface, pattern, component. Okay. Now, I said that I'd like to get through this and take a look at Euclid real quick, because this is important. Euclidean space. 10 of you gearheads out there. That's what I'm looking for. That one. These reference planes, you have to look at them in terms of it having 1, 2, 3 sides to it, emanating out in almost a star pattern. In a star pattern. Euclidean space and Cartesian coordinates, and ultraviolet UVW coordinate systems are interchangeable. It's how the geometry talks. It's the language of machines. I just wanted to bring that up because it's important, and I referenced it in one of my presentations. But again, it's all based on the work of Euclid. He's a Greek mathematician from way back in the day, mid-4th century BC. And all these principles still hold true. You know, that's why I tend to go and I go back and I do my research. You know, this guy's one of those guys, he's kind of, I'm not saying he's like me, but he doesn't leave his cubicle. You know, here he is, he's out of the cubicle. There he is, out of the cubicle for a while. What does he got? Let's take a look at him. He's carrying a scroll. He's got a small little, he's got a telescope or something in his right hand. Anyway, you remember something. These folks, you know, we're not remembering them because they didn't contribute something to the society of the times. As a matter of fact, it's apparent to me that he had some important things to say, and it's held true over the millennia. It's held true over the millennia. So, I bring it up now because we're at that phase. We're at that phase. So, dividing these surfaces can be something that's going to be challenging to us. So now, applying patterns. Let me just check this stream health to make sure that I'm not talking to the wall. It's on a little bit of a delay, but I believe I have the audio on. I hope I have the audio on. If I don't have the audio on, this is going to be a really short exercise. I have the audio on. All right, so let's get back to Revit and applying no pattern. Surface pattern, no pattern. Okay, no pattern. Applying a pattern. Editing the pattern surfaces. So, hold that note. Because I see something a bit different here with this checkerboard panel. Ah, that's what I meant. Yeah. I want to look at this in Escape for a second. Let's see if it updated. I don't see it in there. Let me just do a quick cut over here. Oh, that's because it's not loaded into the project. Let me load it into the project. Curtain wall custom RVT. You can load it into families too. Open families. Let's put this in here for a second. Over here. Mass contains only mesh geometry, which can't be used to compute mass floors, volume, or surface areas. Can it reflect light? That's my question. As long as it can reflect light, and not yet, it can't. So let me go back to Revit and just go back to Inkscape, and do a pause, and do a live refresh of the cache, and see if that'll give me what I want. No, am I missing it because of the cut plane? It's a possibility. It's a possibility. Let's take a look at this crop region, shall we? Well, it's within the boundary of it. Let's go to a 3D level. No, a 3D level here in project. Well, there it is in 3D. We'll go back to Inkscape. There it is. Oop, no, that's not it. It's not there. Not yet. Not yet it isn't. You're going to have to give me a minute to fumble through this. Give me a second. I don't see it yet. Now, could it be because I haven't refreshed my my window here in the encoder? Let me just double check the encoder and double check the capture window. Make sure there's not a doubling up. And it looks like it's okay. But it is not updating. And it could be because of the fact that it doesn't have a pattern. Could very well be. It has no pattern whatsoever. It only exists as a mesh. Nor did the mesh show up. If you look at it in Inkscape, because it had no material, nothing showed up. Nothing came to the shell. It didn't have any material to absorb light or reflect light, except for that extra parabola. Except for that. So, editing the surface pattern. There will be situations where you want to edit and control the border conditions for pattern surfaces. Pattern surfaces may have border tiles that intersect the edge of a surface. Let me go back to, I gotta get some video on here, or it'll stream me out. I gotta get some moving video. It needs something to reflect against. All right, so remember me fondly. All right, so we're back in Revit, and we're talking about editing the surface pattern. So there are times where there will be situations where you'll want to edit and control the border conditions for pattern surfaces. Pattern surfaces may have border tiles that intersect the edge of a surface. They may not end up as complete tiles. You can control the border tile conditions by setting them to partial, overhanging, or empty in the border tile instance property of the pattern surface. Partial, overhanging, or empty. You will now modify a conceptual curtain wall to examine how the different border conditions affect the surface. Start by opening C13 square panel border RFI. We got a lot open. C13 panel border RFI. It's starting to look like a reptile's exoskeleton. It's looking like a reptile's exoskeleton. Or an eyeball. An eyeball. A compound eyeball. Alright, so select the surface. And in the Properties palette, locate the border. I'm looking, the Properties palette. Border tile. I don't see border. I see a constraint named border tile. Let's just double check. Okay. Locate the border. Well, I read it wrong. Locate the border tile parameter under constraints. Set the value to empty and click apply or drag the mouse out of the Properties palette. So let's select this to empty. And it does just that. Any partial tiles that don't meet the edge exactly are going to be considered empty tiles. Now these are all right. They made it there perfectly. But if we look at this side, you have some problems on that side. Did it do the same thing on one side as it did on the other? Well, at least it did do that. It's symmetric. How about on the edges? I'm not 100% sure about the right edge. Well, it kind of looks like that. We'd have to actually count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, looks okay. On that side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unless, of course, they condense the sides of the octagons. 3, 4, 5, 6, a hexagon, pentagon, polygon, as the polygon. Notice that the tiles at the border is no longer visible. Next, change the border tile parameter to overhanging and click apply. And it did just that. The border tiles will now show in their entirety, extending beyond the edge of the surface. Editing a surface representation. When editing a surface in the conceptual design environment, you have the option to choose how surface elements will be displayed. A number of options are available to you, allowing you to customize how you show or hide the various elements that make up a divided surface in the view. I wish I could hide that dog's view of whatever it is that's making it bark. That's another thing about this neighborhood. There are so many dogs in close proximity. All they do, when there's nothing to do, they talk to each other. And they from block to block. It's kind of comical. When editing a surface in the conceptual design environment, you have the option to choose how surface elements will be displayed. Excuse me. A number of options are available to you, allowing you to customize how you show or hide the various elements that make up a divided surface in a view. If you select either the U or V grid icon, this will enable or disable the UV grid in the view. The surface icon allows you to display the original surface, nodes, or grid lines. The pattern icon allows you to hide or display the pattern lines or pattern fill applied to the surface. So take a look at that. A number of options are available to you. Let you show or hide your various elements that make up divided surface. Well, there's the divided surface. And we talked about that. Surface shown and pattern shown. Well, there's the pattern. There's the surface and the pattern, and there's just the surface. And here's the V grid. There's just the U grid. There's just this, the form. Considered a divided surface after it's a form. I'm sorry. That's right. It was a form until we divided it. Now it's a divided surface. Form, once it's divided, becomes a surface. A plat map. It could be a topographic solution. Now, these particular buttons will enable or disable either the UV grid icon, the UV grid, the surface pattern, the surface, which we saw, nodes or grid lines. nodes or grid lines. So just know that if there were any nodes or grid lines that were superimposed onto this pattern, the way we did it in the previous exercise, where we divided the surface with intersects. An intersect could be considered a node. And again, these words hold true. They hold true. They hold true. If you look at their definition and then you look at some of the images, you'll see and know that there's a lot of meanings to a node. In any telecommunications network, there's lots of nodes. But it's another one of those ambiguous words. GitHub, JSON, there are unique identifiers. They're unique identifiers. And if I put a node definition, which is going to defeat the purpose, because a node is a definition to a certain extent, you'll see that it appears a lot in computer telephony, but it also appears in the realm of physiology, and biology, botany, all those good things. But in a computer network, for any of you who are interested, it's a device or data point in a larger network. Connection point, redistribution point, or communications endpoint. Nodes are devices or data points in a large network. PC, phone, or printer are considered nodes. Everything is addressable. And again, I don't want to go off on a tangent, like sometimes. In medical terminology, it means a knot, which makes a lot of sense. A nodule is a small node, a little collection of tissue. We can watch Dr. Pimple Popper if you ever want to, if you're into that. And I've watched that, actually. Believe it or not, I like that show. But I haven't really watched any regular programming in a long time. I've been dedicating myself to due diligence with the platform. So not to go off on a tangent, but we're not done yet. We're not done with creating complex curtain walls. We're still in the editing surface pattern. So we saw that we can turn on and off the UV grid and disable the U and V grid, and we can toggle the surface icon on and off, which allows you to display the original surface or nodes or grid lines that were superimposed onto that surface or pattern. The pattern icon allows you to hide or display the pattern lines or pattern fill applied to the surface, which, again, we'll get more and more into. The component icon allows you to hide or display the pattern component applied to the surface. If you decide to make any changes to the display using the surface representation tools, these changes will not carry through into the project environment. To globally show or hide surface patterns, you will have to alter this from the visibility graphics overrides dialog box. If you decide to make any changes to the display using the surface representation tools, well, we haven't yet. The surface representation tools. Well, if we take a look at the surface representation, the only thing we've done to the surface is just divide it. It was a void. We divided the void into a surface. But the key word here is component applied to the surface to globally show or hide surface elements. You will have to alter this from the visibility graphics overrides dialog box, which we're not going to do this time. Because we could go up to view visibility graphics, and we can go, and there is going to be either an analytical or model category for surfaces. So let's just take a look. Not in the model category, but lines, planes, reference lines, Imported categories, object styles, reference planes, points, lines, adaptive points, model categories. Let's just take another look through here and make sure it's not hidden within like detail items or something that would throw us off on our search path. As you take a look, this is where we would have to independently turn off the patterns here globally in order to have it within the project turn off globally. So the pattern fill and pattern lines. All right, so always good to know. And a lot of times that'll frustrate you looking through the visibility graphic overrides because you can't see something or you don't want to see something. And you have to drill down so deep in that display visibility hierarchy pyramid that I showed you for 20 times already, that it could get perplexing. And the last thing you want to do is be digging in dialog boxes. But there has to be enough of it so that there's that much more customization. Like you're not going to have the power unless you're going to have the ability to apply levels of dialogue to it. We're articulating, opening up dialogue boxes. We're speaking. Not much has changed. Even though I know it's a computer and all, not much has changed over the eons. We're talking, and some of us are listening. Some of us are listening attentively. Some of us are listening the other way. Oh, I don't want to hear that noise. And they listen the other way. We got Mrs. Softy to join us in this serenade. But let's get through this. There's still more to get through. Now, in the surface representation panel, you'll also notice a small arrow in the bottom right corner. So if we go to the surface representation panel, it's like the surface representation panel, you notice an arrow in the lower right corner. We went through this. Clicking this arrow will open the surface representation dialog box where you will find additional display options for the surface, patterns, and components. You also have the ability to display nodes and override the surface material of the form. Let's practice controlling the surface representation of your form. Start by opening C13 Square Panel Surface. Well, okay, I will. That's another one. Open RFA Family Square Panel Surface. It's going to be in the, wherever you download your companion files. C13, Visualization Remap. No, that's 12. C13 Walls, and it was C Square Panel Surface, right? Rep. Wait. Yeah. C13 Square Panel Surface Representation, .rfi from this book's webpage. So we got that one open, surface representation, and I can see it's full of nodes. Okay, I like it. I'm just letting you know off the bat, I like it. I like the pattern. And these are some of the hardest things to draw. And if you don't think it's possible, go walk around Manhattan or any major metropolitan city, major metropolitan area, here to Timbuktu, and you'll see that this comes to fruition. It's not some fantasy that exists in a virtual vacuum space. If you can think about it, it comes to reality. It actually, you can realize it. You can realize it. And I think I've shown you example after example of that. So we have a C13 Square Panel Surface open. With the surface selected, go to the Surface Representation panel on the ribbon and click the arrow in the bottom right corner to open the Surface Representation dialog box. Whew. Okay, the Surface Representation dialog box. I'm talking to the wall. I've got no one else to talk to. So I guess I'm just talking to the wall. The Surface Representation dialog box. Is that not just ironic? The Surface Representation dialog box. Echo, 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 echo. We still have some left to do. We still have some left to do. But Extreme Health seemed okay. I'm probably not as healthy as Extreme Health. My health has been compromised over the years, but this is the time. 51 years old, this is the time to turn that mirror inward, that other display representation that you see, surface representation that you see, and I see from time to time when I look in the mirror. Eventually, you have to say to yourself, okay, well, it's obvious that when you push yourself to the extreme edge, you know, eventually you're going to say, well, wait a second. Haven't I risked enough? Haven't I risked it enough? Isn't it time now to maybe pass the baton, if you will? And before I started smoking, I was fast. I used to run in relay races in Marist High School. And then I started to smoke. And every day after that, my lungs dried out just a little more. So, I know the cardiovascular and respiratory problems that I'm developing at the age of 51, and that actuarially, statistically, by the numbers, the chances of me making it to a certain number have odds. They have odds. But numbers don't lie. So actuarially, again, even if I slow down, it's still a risk, right? They say pack years. So again, open the surface representation dialog box. But I also heard, just not to change subject, but I heard that it affects the vocal cords. Smoking has a very positive impact on those vocal cords. So, elasticity. On the Surface tab, enable nodes. If not already enabled, this will display a node at each intersection of the UV grid. Well, they're on. UV grids and intersection lines are on. Original surface, that's on. Material, we haven't added any material. Adding definition. So far, you've created a surface, subdivided it, and applied graphical representations to the form. You can now begin to add actual component geometry, similar to mulligans and panels, although the underlying graphic pattern will remain. The component geometry will take precedence. To begin this process, you will create special curtain panel families using the curtain panel pattern-based RVT, or metric curtain panel pattern-based RVT family template. So these families exist within this, these RFAs exist loaded already into this next project file that we're opening up. So we have two projects open and multiple families open all at once. I was going to make sure they don't make me do it again because I'm going to start closing some windows. But so far it hasn't really given us a problem. No. Still wants to open up more. And another RVT. So we've got a bunch of pages to go. We've got a lot to do. And we're getting through this today. We've got a few pages to go. So again, I don't want to deviate from center. So we're going to have to open this pattern-based RVT. Pattern-based RVT. So we'll close the surface representation dialog box. We're going to go back to this this particular project. I'm going to close curtain panels, curtain surface panel. I'm going to close all these open RFAs. And not save any of the changes. I'm going to leave open surface panel, surface representation. I'm going to close out of curtain wall custom RVT, which was the RVT project file, and say no to that. And we should have only two families loaded now. We have the square panel border, which is a dome for a stadium, if you really think about it, and not saving any changes, just in case. And I'm leaving open the square panel surface representation, rather family. And we're going to go forward through to adding definition. Again, opening up the pattern-based curtain panel pattern-based RVT. Open. curtain panel. Let's see here. Oh, it's a family. So then hold that thought again. It's a family template. I don't see it as part of the downloadable families that came with the Buildings Companion website. So we're going to have to go to the library, and it's most likely in there. So again, C, Program Data, Autodesk, RVT, not Revit Server, RVT 2020, Libraries, US Imperial. Let's take a look at this now. Now we're looking for curtain panel pattern based. Curtain panel by pattern. Curtain panel. Look, it's looking for RVTs or RFAs. And you see in this directory, I don't see any RVTs. I don't see any RVTs. Curtain wall panels. If you look there, I don't see any RVTs. So, I'm going to have to read this again. It must be a template that we can when we create a new family. We'll have the option of choosing a family template. That's just what it doesn't say that, but if I remember correctly, new family using an RFT, not an RVT, an RFT. That's right. So now you'll see in this directory, which is a different directory, in the root program data Autodesk RVT 20 family templates English I directory. There are family templates, RFT files. So now, if I can get this stupid type selector window out of the way, you'll see that we're looking for curtain panel pattern based. It's tough to say. Say that 3 times. Take a tongue twister. Curtain panel pattern based. Curtain panel pattern based. Curtain panel pattern based. Well, there it is, and it's an RFT. As you can see, there's a little preview of it here, the thumbnail. Let's open that up, and it's going to be an RFA, right? It's Family 91, right? But when we save it, we go to Save, saves the current family, and you'll see the file extension. It's an RFA, not an RFT, nor is it an RVT. It's an RFA. It's going to be a family, based on a template that we use to create the family, and there are lots of them. And this one just so happens to have adaptive points. Adaptive points. So, monitor my behavior. This is staring into a scope all day. It's murder on the eyes. It's murder on the eyes. You can get migraines, especially when your mind is moving as fast as the software's. Could really play havoc. All right, so you're going to be cognizant of that. But again, I'm just looking for an excuse to get out of doing this exercise to the finish. I'm not going to quit just yet. Now, figure 13.58, which is what you're looking at on the screen, basically, which is basically what you're looking at, shows the pattern-based curtain wall family template, which consists of a grid and again, it's just a tile pattern grid. It's a pattern. A series of reference lines. Look at it top. So if we select everything and look at the filter, there are reference lines, 4 of them. And adaptive points, 4 adaptive points. And it appears that, look at it from the front, I don't see any reference lines in the Y elevation. I see the pattern, but it's the reference lines that I'm trying to find. And I want to select everything again. take a look at the filter. I'm going to turn off adaptive points and just select just the reference lines. Reference lines, 4 of them. And they're selected. Now notice that they're shaped like the Euclidean vectors that I was talking about. If you see this reference line, it's more of a Euclidean vector than an actual single linear line, right? Again, I just want you to make note of that. It's a form. All right, so adaptive points. The grid is used to lay out the pattern of the panel. The adaptive points and reference lines act as a rig, defining the layout of the panel. You can construct solid and planar geometry within and around the reference lines to form the panel. When a panel is applied to a divided surface, the points in the panel adapt to the UV grid, and the panel will then flex accordingly. As a general rule, the grid pattern in your curtain panel family should match the pattern on the divided surface to which it is applied. Okay, well, we saw that. That's why we apply it to it in the first place until we get it right. Then we switch back and forth between surface and pattern. So the pattern of the divided surface, the grid pattern should match the pattern on the divided surface as a general rule. So if we create a family with a pattern, it should match the pattern that we're going to be applying it to it in the model that exists within the project. For example, if you applied a hexagonal pattern to your divided surface, make sure the curtain panel family is also using a hexagonal pattern. You now need to decide what pattern you will use for the component. Well, for starters, let me take a look at the stream health. The audio stream's current bitrate is 0, is lower than the recommended bitrate. We recommend that you use an audio stream bitrate, now it's okay. So far so good, it's a healthy stream. No one's paying any attention. That's fine. All right, so back to Revit. Adaptive points. Okay, so for the component, we're going to be creating a component. If you ever saw component cables, a component. A part or element of a larger whole, especially a part of a machine or vehicle, stereo components. Constituting part of a larger whole, constituent. Light passed through a prism, breaks light passed through a prism, breaks up into its component colors. Well, we've seen that. I'm sure if I've been able to illustrate anything, that's what I have been able to illustrate. Now, let me just get back into Revit. You now need to decide what pattern you'll use for the component. To change the pattern, select the grid. Go to the type selector and change the pattern to rhomboid. Okay, we'll select the grid. To rhomboid. Rhomboid, right there. Notice how the adaptive points and reference lines update to reflect the change. Review the various patterns that are available to you. Revert to the rectangular pattern. Well, we've gone through a lot of these, and a lot of them are pretty cool, and how it's adaptive. So adaptive. You see, it's just showing the one triangle checkerboard, the actual pattern, the individual pattern of just what's going to make up this entire wall, this entire panel surface, what's going to make up this divided surface. And as you can see, the adaptive nodes, the adaptive points follow suit. Bidirectional associativity. And then settle on triangle, rectangle. Settle on rectangle. Modeling a pattern-based curtain panel is similar to how you would sketch and construct a form within the conceptual design environment. Use points, lines, and reference lines to construct geometry. Select one of the adaptive points and drag it. Wasn't that the cat's meow? In that view, we can drag it up and down. In the top view, can we move it left and right? It appears to be constrained in the X, Y, but not constrained in the Z or W, depending on your perspective. UVW, XYZ, right? It appears to be constrained in the X and the Y, but the Z is variable. These points move only vertically, not horizontally. Okay. That's deceptive. As you move the point, the reference lines attached to the point will alter the shape. Therefore, as you build geometry on the defined reference lines and an adaptive point is moved or adjusted, the reference lines are altered. Not to mention, if we constrain something to the reference plane. And the geometry constructed along the reference lines updates to reflect this change. Now you're going to start to see, you go into a production studio and they hook these nodes up to your body of an athlete running, and then they take those and they put it into a 3D studio program and apply a skin and a surface and a model avatar to it. And nowadays you can't tell whether it's live or whether it's the person itself, this hologram, if you will. You're going to have a digital twin whether you like it or not. We are so far out there, man. We are so far out there. We've got to beam back up to the bridge just one of these days. All right, so yeah, if they're altered, the geometry constructed along the reference line updates to reflect the change. To reset the adaptive points to the grid, select the grid, and you will notice a reset points. If we go here, let's see. Well, I haven't moved any. Resets points to grid. That's good. Okay, to grid button in the options bar. Click the button to reset the points. Select the 4 reference lines and click the create form. Reference lines 4 and create form. Solid form button on the ribbon. 2 icons now appear in the middle of the model. We've seen this. We've got 2 choices, right? Giving you the option to create an extruded form of flat planar surface. Select the icon for the planar surface. Next, you will flex the geometry to test its consistency. Select one of the adaptive points and move it vertically. Observe how the geometry flexes, as shown in figure 13.60, and then reset the points to grid. If I can. And I could have sworn we had to grid. Select the grid, right? And reset points to grid. Okay, there we go. All right, so, well, it flexes, just like I showed you in that quick family tutorial way back when I showed it over the joint board with the light fixture that we created in the sandbox. Switch to the architectural tab. Well, we're not in the project yet. And then reset the points to grid. Switch to the architectural tab in the ribbon, and from the draw panel, select the point element tool. Place a point on one of the reference planes. Well, we haven't loaded this into the project yet. In the architectural tab, well, we don't have an architectural tab. We have a create tab, and then there's the point element. Switch to the architecture tab in the ribbon, and from the draw panel, select the point element tool. Creates a reference point that you can use when creating a new family or to create constraints for the family. Reference points provide 3 planes on which to sketch lines and forms. Reference points can be used to create 3D splines and lines, and they can be hosted on lines and surfaces. And we discussed this a little bit in the massing, complex massing. So we have a point, and we could place it on the surface. Place a point on one of the reference planes, on a reference plane. Well, there's a reference plane. We can put it at the midpoint of this reference plane. And that's where they put it. That's where they put it. Theirs looks a little different than ours. This point becomes a hosted point. Observe how its symbol is smaller than the symbol for the adaptive points. Select the point, and from the Properties palette, change the value of the Show Reference Plane parameter to always. Well, that's because the parameter is off. The parameter here, you can see the reference plane associated with it. And if I do Show Reference Planes, and we talked about this a little bit, always. And there's the reference plane for that point. This will make it easier to build geometry using the hosted point in later steps. From the Architectural tab in the Work Plane panel, click the Set button. Set Work Plane tool and pick the work plane of the hosted point. Got it. Uh-oh. Draw a circle with a radius of 6 inches or 150 millimeters on the work plane of the hosted point as shown in figure 13.62. So now the radius is up here. Where's the radius? To activate it. A radius is 6 inches, 12-inch diameter circle. Put it right there. As shown in figure 13.62, which I got. It can be a little tricky drawing the circle onto the active work plane of the hosted point. Therefore, use the Show Work Plane tool to display the active work plane, and that's always good to do. But again, sometimes it can be a little confusing if you don't orbit around to see exactly where it is. But it is indeed on the surface of that reference point. So we can toggle that off because we know that it's there, and it's there. So, and notice how the reference planes kind of stay the same size. As you zoom into something that gets larger, the reference plane for that point is inversely proportional to your scale factor. It keeps it the same size. All right, so, select the circle and the 4 default reference planes and then choose Create Form, Solid Form. So select the circle by hitting Tab and hold down Control and select the 4 reference points. And then Create Form. And as you see, you have 2 options. This will sweep the circle profile along the 4 reference planes, as shown in figure 13.63 or in this figure, which it didn't do. The circle form, it didn't do it. Let's see. Select the circle and the 4 default reference planes. Adaptive points. Oh, 4 default reference planes. I hate the 4 reference planes. Chain of walls or lines. Let me see what I got selected. Hold down Control. Oh. Now let's take a look at the filter. Reference lines. 4 reference planes. Again, that's going to make a difference if it's the line of the plane. Any of that. This will sweep the circle profile along the 4 reference planes as shown in figure 13.63. When building your curtain panels, consider how you will assign geometry to appropriate subcategories. This will ensure that you have full control of the elements from a visual and graphical point of view. For details on assigning geometry to subcategories, refer to Chapter 16, Creating Stairs and Railings. Save the family as Square CW Panel RFA. File. Save as family. I guess I could save it here for now, even though we'll probably have to use it down the road maybe. Square-CW panel. Square-CW panel. RFA. Oops. Okay. Changing patterns with geometry. It is important to understand that if you decide to switch your curtain panel grid pattern, After creating solid forms, the geometry will not automatically adapt to the new pattern you choose. The geometry will be left orphaned, and you will need to delete any geometry and remodel based on the new pattern. Okay. Applying components to a divided surface. Now that you've created a pattern-based curtain panel family, you'll need to load this family into your conceptual mass family and apply it to the divided surface, replacing the graphical pattern with the actual component. Download and open the C13 Square CWS System RFI from this book's webpage. Open. Where is it? Square CW System. Square. Anyone see it? Square. Am I in the right directory? Square. I don't see it. RFA, C13. RFA, C13. Okay, well, let me take a look here. I downloaded it before into another directory as a backup. CW System. It's here in the new download. Let's see if it's in the old download, unless it was deleted. Walls, C13. CW System. So it is there. Okay, so I was misled. All right, so there it is. It's an upgrade from 2018 to 2020. Load the family file Square CW Panel, which we still have open. Square CW Panel RFA. By clicking Load Family on the Insert tab of the ribbon, or switch to that file and click Load into Projects button, which we just did. Load into Projects. Now we have two RFAs open. We have CWS System RFA and the Panel Surface Rep open. So I left it open. This is the one we just opened. Let's put it into this family. So we're nesting in a nested form, right? And again, it's in there. It's loaded. It's loaded. We're back in system, but it's loaded into, I believe, surface panel representation, which hold on a second. No, I just got confused. I loaded CW System into surface panel representation, whereas we're supposed to load CW Panel into CW System. So I saved it and closed it. This is not the family we should be loading. So let me close this. Open up CW Panel. If we go to recent files, it'll be right there, hopefully. Square CW Panel. Right, and now load it into project and close. Well, the only open project is C13 Square CW System. So it's in there. Okay, in the conceptual mass file, select the pattern and divide the surface. In the properties palette, click the type selector and scroll down the list until you find the name of your pattern-based curtain panel family. In the conceptual mass file, well, this is a divided surface, right, with a pattern on it. Well, being that it's a CW System RFA, it's considering this, it must have been created with a conceptual mass template. Select the pattern in the divided surface. Well, we have the pattern, and we hit Control. Let me get both of them, huh? Let's see what we got when I select. Let's just take a look. We got the form and the divided surface. Select the pattern and the divided surface. Well, hold on a second. Let's not get carried away. Let's turn on the surface, turn off the surface, turn off the pattern, select the divided surface, the properties palette, which we can't really do much with, click the type selector and scroll down the list until you find the name of your pattern. Well, in the conceptual mass file, select the pattern and divided surface. In the properties palette, select the type selector and scroll down the list until you find the name of your pattern-based curtain panel family, which is right there. Let's take a look at it. Your new panel family will be listed under the pattern within which it was designed. The component will now be applied to the pattern surface, as shown in Figure 13.64. Note that the more complex the surface and component, the longer it will take to load. And that took a little bit to load. So let's zoom in and take a look at that. Not too shabby, not too shabby, not too shabby. So you can see there's so much more than just these patterns that are simple. There's more complex patterns that we can create within the creation of a complex curtain wall panel, which goes into a curtain wall system. Now that you have mastered the technique of constructing a simple planar curtain panel, let's look at how to create a pyramid type panel. You will add a type parameter to your pyramid curtain panel so that you can vary the apex of the panel. Starting a new family using the curtain panel pattern-based RVT, create a new family using the curtain panel pattern, curtain pattern panel-based, curtain panel pattern-based, RVT, or metric equivalent, template. Place a reference point ensuring that it snaps to the middle of one of the reference lines included within the template. Place another reference point on the reference line opposite the one you previously placed, as shown in that figure or this figure that I'm going to show you. Place one at this midpoint of this reference line and one on the opposite side. From the Architecture tab in the ribbon, click the Reference tool and ensure that 3D snapping is activated in the Options bar. From the Architecture tool, they call them the Create toolbar, Create tab, click the Reference tool. Located in the Options bar. Ensure that 3D snapping is activated. Well, I don't see 3D snap parameter that I could double check though. Hold on. I don't see. Let me see if I hit pick. Will that enable it? No. Edit, undo. Go to the Create panel. Click the Reference tool. Well, reference line, Reference tool. Make sure 3D snapping is activated. Yeah, it says click the Reference tool and ensure that 3D snapping is activated in the Options bar. Draw a reference line between the two newly placed hosted reference points. 3D snapping, 3D snapping. Place another reference point so that it becomes hosted. At the midpoint of the previously created reference line, another reference point. Where did that one come from? Oh, at the midpoint of the just newly created reference line, so that it becomes hosted. Select this reference point, and from the Properties palette, make sure that the Show Reference Plane is set to Always. Select this one, and make sure that it's set to Always. And notice the size of the reference points. I thought this was hosted, but obviously not. That's hosted. I think that's what makes it get smaller in size. Maybe hosted by the element we're going to apply it to. Okay, so I think. Well, this is hosted as well. I'm not 100% sure. We're going to find out. From the architectural tab, choose the Set Work Plane tool and select the work plane of the hosted point at the middle of the previously drawn line. Activate the Reference Line tool and uncheck the 3D snapping option. Draw a reference line vertically in the Z-plane from the hosted point. So from the architectural tab, choose the Set Work Plane tool. And select the work plane of the hosted point, right? And draw a line, a reference line or a regular line. Uncheck the 3D snapping. How am I going to get to the point? Well, I'm at the midpoint. Okay, good. Draw a reference line vertically in the Z-plane from the hosted point. Well, that's 90 degrees in the Z, and that's 90 degrees in negative 90 degrees. I'm sorry, that's 270 degrees. That's 270 in the phase. So that's 90. That's 0. That's 180. And this is 270. And then that's 360. So in the positive Z, right? Vertically in the Z-plane from the hosted point. All right, well, how high? Well, it's a pyramid. So let's just get really high. Ensure that the start point of the reference line is locked to the hosted point. You may need to drag the end of the reference line nearest to the point in the Z direction before dragging it back to the hosted point. We don't have to do that. This will ensure that the lock symbol will appear. Are we sure about that? Make sure that it's locked. You may have to drag the line. Now make sure that the lock symbol appears. Well, I don't see that appearing. So look at it from this direction. You may have to drag it. Hold on. Ensure that the start point of the reference line is locked to the hosted point. You may need to drag the end of the reference line nearest to the point in the Z direction before dragging it back to the hosted point. All right. Before dragging it back to the hosted point. So if I grab the line, if I grab the reference plane, I drag it up in the Z direction, I drag it back to the hosted point. Well, that isn't giving me the lock. There it is. So you get it's a lock. Got it. You may need to drag it to the end of the reference line nearest to the point in the Z direction before dragging it back to the hosted point. This will ensure that the lock symbol will appear. Select the vertical reference line to display the temporary dimensions. And turn this into a permanent dimensions by clicking the dimension icon, which... Yeah, I'm not getting it. Give it to me. Make dimension permanent. I'm not seeing the make dimension permanent command. When you select the dimension, select the vertical reference line to display the temporary dimensions. There it is, right there. Make dimension permanent. Set its dimension and then choose Add New Parameter. That's a label, right? Select the dimension. Select the dimension and Add New Parameter. From the label pull down in the options bar, it was already created for us. Select the dimension, and from the label pull down in the parameter, it's not there. From the label pull down the options bar, add new parameter from the label pull down in the options bar. Well, there isn't any in this version, so you have to create a new parameter and then assign it. Assigning this dimension to a parameter will allow you to alter the apex of the pyramid panel as needed. In the Parameter Properties dialog box, name the parameter apex height. Click OK and close all dialog boxes. It's a dimension parameter. It's a family parameter. It doesn't appear in schedules and tags. It's a type parameter. But, okay, does it apply to that dimension? Yes. Apex height, and it applies to that reference line as a parameter. Add a series of reference lines using the 3D snapping option from the apex to the 4 points of the base of the pyramid. 3D snapping from the 4 points to the apex. Reference log, let's get this so that we don't screw it up, right? And from the 4 nodes, reference points to the apex. You will now create faces on each slope to complete the pyramid shape. To do this, select one reference line from the base and 2 reference lines on the sloped edges. Use the Control key to add lines to your selection and click the Create Form button. Select the planar triangle face rather than the extrusion. Okay, so we go to, let's start with this one. So we'll select this one, Control, this one, and this one. And then we'll create a form. And we'll have a choice, 3D or not 3D, planar. On each slope, so we have to do the same thing here. We have to escape out of that, select this one, hit Control, Tab until we, your sister, tabbed over. Select that one, and I can't select the, just get it. Let me start with this one, it'll probably be easier. Grab that reference plane, Control, grab, let me zoom around a little bit by hitting, so I can do both. I can use my steering wheel right now. Let's grab that one and that one and create a form. Create a surface. And there's that one. So we got 2 left. So same story, select, tab that one, control that one, create form, solid form, surface, got that one, and tab over here, grab that one, hit Control, grab that one. This one's gonna be tough. This one's gonna be tough. Let's tab through it, and then hold, keep Control down. Now we got them. Create form, solid form, surface. Oh, your sister. Undo. I hit the solid instead of planar. Okay. So tab, grab, Control, grab, let go of Control, tab, hold down Control, grab, create form, solid form, planar surface. You will now create faces on each slope to complete the pyramid shape. To do this, select one reference line from the base and 2 reference lines on the sloping edges, and click the Create Form button. Select the planar triangular face rather than the extrusion. Repeat step 9 for the 3 remaining faces so you have a complete pyramid. It is important that you flex the pyramid to check that you can control the height of the apex. Open the Type Properties dialog box and you see the parameter named Apex Height. Change the value a few times and click Apply after each change. The pyramid panel should change in height. It's at 17. Let's bring this down to 24 inches. See if it's constrained. Let's bring it up to 6 feet. Hit Apply. And sure enough, it looks like it's working okay. So we flexed it. Looks like it's working okay. Save your file as Pyramid Panel Artifact. File. Save as. Family. Well, there's a lot of other artifacts in here. So we'll create this as Pyramid Panel Artifact. Pyramid Panel Artifact. Save it there. With the rest of them that we downloaded from the Cybex Companion Books website, Books Companion website. Okay, so creating custom patterns. Although Revit includes a variety of patterns you can choose for conceptual curtain walls, currently there is no way to create your own pattern-based curtain panel template. The current patterns shipped with the software are hardwired, so there is no way to modify them either. However, With a bit of creative thinking, you can use the provided templates to construct panels that will conform to a custom pattern concept. When you consider building a custom panel, it is important to take into account how it will repeat vertically and horizontally. You will need to break it down to its smallest module. If you think about repeating architectural patterns such as a masonry wall, its individual component can be broken down into the block that forms that pattern, which, in essence, is a rectangle. Figure 13.72 shows an example of a hexagon-shaped panel constructed with a rectangular pattern. Now, I'll show it to you. That's what it looks like. Similar. Within a rectangular panel. Once you have decided on the design for your panel, look at how the panel could be modularized. To do this, consider laying out the pattern utilizing graph paper. This will certainly help you better understand the layout before attempting to construct a panel using an appropriate template. In figure 13.73, you can see the hexagonal panel applied across a divided surface. And we've seen that. We've seen that already. Across a divided surface. We've seen that already. The hexagonal pattern. If we were to select this, and you see the pattern, the hexagonal is applied across it. And again, this one is really tiny. It's like, I would say 12 inches. No, not 12 inches. Divider number 2. See, the opposite, 24. Actually, it's probably 48. More along those lines. Notice how it doesn't lock the aspect ratio. It doesn't lock the aspect ratio. In any event, it's similar to that. Similar. 84, 48. 84, 84. Come on. There we go. Okay, so limiting the size the size of a pattern-based family. When designing complex curtain wall systems, the goal is to limit the variety of panels. The more variety you have, the higher the cost, because you have to create a greater number of unique panels. When you divide a surface, the panel sizes can vary quite dramatically. Although you don't actually have the ability to limit panel sizes, you can start to reduce the size and variety of panels by nesting curtain panels inside other panels. In the following exercise, you will learn how to nest panels to limit size variation. But first of all, we haven't applied our pyramid yet. We haven't applied the pyramid panel. So that's bothering me. We created this beautiful pyramid, and I remember loading it into the surface. So let's load it into Project and Close, and then let's select the surface, pattern, and then take a look, and pyramid panel. Let's load it in and see how long it takes. We went through all that trouble, it didn't even tell us to load it in. Let's take a look. Maybe that's why, depending on the complexity of the pattern. And that's a pretty complex pattern for each of these. And being that I divided it up by 84 by 84, that's going to make it even worse. So we're going to have to wait a second. Hopefully I don't crash it, but this is a powerful machine. But look at the processing. It's going to take a while. I'm going to take a look at my feed while it does its thing. Hopefully let me go back to it. Stream health. The YouTube stream analytics isn't as good as Facebook's. It does not have as many bells and whistles. I'm not really too happy with it. But what are you going to do? What are you going to do? It's going to take a while. Testing 1, 2, 3. While it does its thing. Hopefully let me go back to it. Stream health. Give me a second. The YouTube stream analytics isn't as good as... I turned off the audio return. It does not have as many bells and whistles. I'm not really too happy with it. But what are you going to do? All right, let's take a look. No, it's still thinking, and it's only at 0%. So I'm going to let it do its thing. Just let it do its thing. We're live, right? We're live. So I'm going to let that stream through the stream, and I'll come back to it. So I get to take a break. And I'm going to do just that. before we get into limiting the size of pattern-based families. Because there's still a bit more before we get to the bottom line and get to chapter 14. So, not resting on our laurels, it's 6:10. I started this very early in the morning. So, the fatigue's starting to set in a little bit. So let me just hopefully come back and see if indeed this does eventually model, or if I seized it based on the fixed number of panels that we create. I can't imagine that being overwhelming, but it could very well be. So, what did I say, 6 foot? Oh, of course, it's going to be almost like a pin cushion. It's going to be like a pin cushion, right? If this wall is only 10 feet, and I divided it up into 84 pieces with variable width and length pyramids, and try to fit it on a hexagonal pattern, the computer probably doesn't know what to do. So let's just take a look at what it's trying to think about. Let's take a look at the processes that I just put this poor thing through. Let's see what's bothering it. Well, it doesn't seem to be using that much memory, but the computing power is pretty high, right? The GPU card that's higher than usual for me. That's usually never on 33, and it's very rarely pages the GPU processors. It very rarely does it. And it's doing it. So it's going to use all of its strength to see if it can render that for us. And look, it's thinking. Well, let's just let it do its thing. That'll give me time to rest. Remember, the pattern in your family, pattern-based family, has to match the pattern that you're putting it on. And I blew right through that. We would actually have to have a pattern that would conform with the base of the pyramid, right? It would have to be rectangular in shape. But we didn't constrain those with a parameter. Oh, mosquito. We didn't constrain the length and the width or the base of the pyramid with a parameter. So that might have been more fluid. It would have been more constrained to the size we created when we created it in the family and the number of them that fills in each of the UV grids. So I think that's where the answer lies. Let's see if I crash this thing, how long it's going to take to maybe return an error or start to smoke. Let's just leave it like that for a while. I don't know if I can stop the process, but once you see that veiled screen, you know that you're on a whole other wavelength, and this puppy is humming. So that was a mistake. That happens. Limiting the size of patterns. Well, that's what I should have did before I invoked the command. And that would have saved us a lot of trouble, but I didn't limit the size of the pattern. So this one here is going to be a sawtooth pattern on the bandwidth scale. I apologize, but that's how it is. Oh. Limiting the size. I'm going to take a break and turn off the mic so I don't feel as, what do you call that? Invasion of privacy. Kind of feels kind of creepy. Let me just come over to the thing. Just turn off the mic volume. I want you to